Well, hello everybody and welcome to SkyTour Livestream. It is 1122, January 1st, 2022, the first stream of the new year. And who better to initiate it with than with Daryl Mason. Hi Daryl, how are you?
I'm good, Mark. How are you?
I'm doing very well. It's good to see you.
Music's really stepping on you. Let me see.
Well, again, it doesn't happen over the stream. It's only behind the scenes. So, hey there, everybody. Welcome, PG. Welcome, Fantasy Ecstasy, Daisy and Zoe Amethyst. Charlotte is here. Nice to see you. Satisfying Animations. And Leslie Latin Taylor. How are you? Good to see you guys. And we are going to have a fun time. Donald Kunzer is here. He said he'll be back. He had to run out for a bit. But it's nice to see you guys. Tonight should be fun because we don't have a moon. We have a clear sky. At least for the moment out there. You know. Daryl and I were talking about the weather earlier. How's it going out there, Daryl? Is it? You said it's gonna be below zero tonight, possibly.
It may hit zero tonight. Your music is really loud, Mark.
It's not okay. You're not.
We're back where we were a few weeks ago. I can barely even hear you.
All right. It's actually. It's not. Nobody hears that but you. I know how to fix it. I do. So let me fix that. In any case, while I'm doing that, guys, just hang in there for a moment. If I can only figure out how to get to that. All right, here we go. Is it this way? Okay.
I don't hear the music at all now.
I know you don't, because I've actually stopped the share too.
Fantasy says he can't hear me.
Well, you're definitely going out. Okay, let's try this. Okay. I assume you still hear the music, Daryl?
No, I don't.
Okay. All right.
Fantasy, my sound is up louder than usual on my end.
Okay. So the question becomes, Daryl, let me see if I can increase your sound a little bit, Daryl. So as you talk, we'll see. Oh, let's see. Now it's better, Daryl, she says. Or Fantasy says. Fantasy is male, I believe. It's hard with the names, you just don't know.
Testing, 1, 2, 3.
The classic old testing, 1, 2, 3 routine. The testing 1, 2, 3 routine. Yeah, so tonight we're going to look at some really cool objects. Orion is starting to peak up high enough that we might actually be able to check it out. It's going to be really, really nice in there. Anahata 77 will enjoy it too. That's Bonnie. Hi there, Bonnie. Pam Strutman, how are you? Nice to see you. So we're going to have a lot of fun. I'm waiting for the telescope to come into cool temps. It's there, and now it's at -10. Now see, what's interesting is this telescope, just like the James Webb, has to run at ultra-cool temperatures in order to show you the things that it sees. The James Webb requires it because the infrared sensor can't handle any heat, which is infrared energy, that causes it to get warm. Right? It's going to be at literally -255 Fahrenheit, pretty much at all times. It might get lower than that, actually. So the temperature has to be really low, and that low temperature will allow for these beautiful images to be captured. That's the thing. So we're going to take care of that here by dropping our temperature not to -255, but only to -10 Celsius. Right? So not bad. Not bad. So, yes, Bonnie, yes, this is a great way to start the new year with a stream. Let's hope the sky is beautiful and that everything works fine. I'm going to bring up one more program that we usually run, and that is our focusing system. This focus system is something that I can automate, which I've told you about before. So what I'm going to do is I'm going to leverage the capability of it to autofocus. It's going to actually, it won't do it tonight. Tonight we'll do it by hand. But it's going to be something that we can do on the next night. The telescope will go back and forth and hunt for the best focus and stop right there at perfect critical focus. I think that's a pretty cool, add-on there, Daryl.
It is. I assume it'll be gauging pixel size or star size.
Yes, it will. It's going
Try
to
to
use the
shrink them
built-in...
as small as possible.
Exactly right.
Yeah.
So to give you a little preview, if we go into the tools here, which you can't really see all that up there, but that's okay. We have down here, we have Focus Assistant. And the focus can be done a number of ways. And what we're going to do when we do it is the full width half maximum measurement right there. And that's going to be used by the telescope to determine how you get really, really tiny stars. It's going to move the focus in and out until the stars are the smallest possible. And we couldn't do that until this was collimated. But now that it is, it's there, and it's going to stay just like that. So Andy Morrow's here. Hey, Andy. How are things over in England? Good to see you. Satisfying has a question. Why is the screen FPS low? Are you talking about when we're taking imagery? The screen, like right now, our screen FPS is 1 frame per second. But that's because we're using a camera that has pretty high sensitivity, and it allows us to see a 1 second shot every moment so we can see what's going on. You're not going to find a camera that gives you like 120 or 60 frames per second or even 30 frames per second with the sensitivity that we have. All right, you're not going to find that out there except with lots of noise on the image. And what we do is we actually remove almost all the noise dynamically. So the noise will be gone when the finished products come out. And incidentally, speaking of finished products, when we take pictures, within minutes, they go to our server thousands of miles away. And they get sent via satellite, actually. And they end up at a server location that is published on my Facebook site. It's on my SkyTour LiveStream site. It's a pinned post at the top, Facebook. And these, if someone has that link, they could stick it in here. And that will provide you with the imagery for tonight. So if you're just joining us... What's that?
Working on it. Give me just a sec.
Oh, cool. Thank you, Daryl. So this is the camera control section over here. Up above my head here, this is the telescope in the building, and above that is the telescope control center. Okay, this down here, right here, is actually the view into the telescope, and what we do is, that allows me to see what's going on in the telescope computer. Now, I also can go into what I call my hyper mode, which allows me to really, really brighten the view like this, and now you can see more stars, right? And I see Jessica Baker is here, and I see Marianne Robb is here.
Hi, Marianne.
And Rockstar is here. Marianne, of course, is our amazing project director for SkyTour Livestream. And I don't see any trolls, Amal. We haven't had anybody trolling us in a long time. At least none that I saw. Oh, wait. Yes, you're right. Jessica Baker. Okay. Thanks, Amal, for pointing that out. So, and PG, of course. That's Petita. She lives in Pennsylvania. And, all right, so here we go. So what I'm going to do now is at least get us get us targeted. We're going to make sure that we're able to target a specific object tonight. I actually haven't had the telescope doing this for probably close to 3 weeks now. So what we'll do is let's start out with the Triangulum Galaxy. We're going to try and just go to that. All right. So here we go. And you'll watch the telescope move over my head, and it's going to pick a bright star near the Triangulum Galaxy. All right. And there it goes. And so that bright star is going to be brought into the view and centered. And then from there, it's going to hop over to the Triangulum Galaxy. It's a high precision pointing system, which you see right here. High precision. Okay. So that looks like the star we're picking. That looks familiar. That star looks familiar because there's a little tiny Messier object or NGC object right near it. I forgot what object that is, but that's okay. And then from here, the Triangulum Galaxy will be brought into view. It's centering it. You can see it's auto-centering. This is Mirage. Okay, the star Mirage. All right, and it centers it, lower third, and then boom, off it goes. And the blurry thing you see in the screen is Messier 33. Ah, I love when a plan comes together. Yep. I was stopping talking because I thought maybe that, you get tired of hearing me talk all the time. I'm going to change the speed of motion here. Daryl, you said you were looking for some really cool objects today, yeah?
Lately, actually for the last few weeks.
Yeah?
Yeah. Checking various sources. There's one site on YouTube called Astro Video of the Day. They're not associated with APOD.
Okay.
Astro Photo of the Day. It's some guy from India. But he's putting up some really neat videos and all sorts of stuff. Hopefully I can remember in the months ahead. I should be writing them down. He covered Leo, the Leo triplet, and the M96 group yesterday. And y'all may remember seeing the Leo triplet group last year. M66, M65, and the so-called Hamburger Galaxy. And then there's also M95 and 96, and I think he's gotten into Virgo, which will be great when we get to see Virgo in a month or two,
Sure.
if we stay up late enough. Virgo cluster galaxies and all sorts of stuff.
Yeah. He did the Medulla Nebula, which you sent me the other just a little while ago. The
Oh,
jellyfish,
yeah.
basically.
Yeah, I think it's the same as the jellyfish. And some of the images he shows, some are amateur, some of them are professional observatory imaging, though, and Hubble and stuff like that. And the image scale, I think, is, just the aperture of the telescopes and stuff is beyond what we're capable of. But nonetheless, trying to pick out which ones I know we can see. And, the ones in Leo and Virgo, for instance, I know we can see and should make some great viewing in the weeks ahead.
I think so. Well, thanks for that, Daryl. I think that we're really looking at some pretty good sights. I can tell you this: I'm really excited because Orion is cresting over the eastern side of the observatory, and I'm really, really excited to be able to show you some of the stuff in Orion. And if we stay up long enough, we might be able to get to, you ready for this? Thor's helmet, sorry. Might be able to do Thor's helmet. And
Orion is an evening object now. It's west of the meridian by midnight. And actually, so is Sirius now in Canis Major.
Yep.
And if I remember right, Canis Major is where Thor's helmet is, right?
Yeah. It's just east of the main constellation, the asterism, the main constellation of the Great Dog. Hey, Charles Smar. All right, and now what we're gonna do is we're gonna try and do a 35-second exposure. No, I'm just gonna go 25 seconds because no, I'll do 30. Make up your mind, Mark. I will. No, you won't. Yes, I will. I'm not schizophrenic. Okay.
You're never alone with a schizophrenic.
Says us.
Yeah. Who, me?
Right. Who, me? No, you. What, who? I don't make fun of it because obviously I'm very sensitive to that. I know people that are unfortunately afflicted with that. Okay, so here we go. Let's do a 30-second exposure, and let's live stack it. Now you see all that noise in the image, all those granularity that we see there. Obviously, we want that to go away, right? And this process, that's by stacking it, will actually make it go away. It'll take a bit, but it will. All right, so this green bar over here gives you this one here. You see the green bar, that's the status bar. Shows you the progress on the exposure. 30 seconds and boom. Oh, look at that. We've got satellite in there, and we got a little bit of color. It has to be changed here. We got to change the color adjustment. There we go. Look at that. Wow. That's pretty. It's already pretty. Let's see if we can stretch that a little bit. Yeah, we got this satellite coming through here. Wow, that's neat. So what we can do right now is we can take this, first of all, let me lock this in, and there you go. Look at that. Wow, that's really pretty tonight, and it looks like the focus is pretty good.
Yeah.
I have to do one thing. I have to go into our guiding system, and I'm going to go in and set the guiding rates to something a little bit better than what it is. Instead of +6.6, I'm going to go to +0.5, and then on the up and down axis, that was east-west, right ascension we call it. And then on the declination, we're going to set that to a much smaller correction because not a whole lot is needed near the pole. And that's 0.1. Enter. The telescope has the capability of figuring out the rate itself, but I do it manually. Leslie, I'm glad you're liking this. Hi, Oofy. Oofy's here. Yeah, actually, you like that, Oofy. Let me make a little modification to look even better. We're going to go do an enhancement. We're going to actually add some dynamic sharpening to this. It's called an unsharp mask. I'm doing a little bit, not a lot, but watch the galaxy get sharp. Look at that. Wow. Look how much sharper it just got. Isn't that crazy? Wow. Yeah. Actually, let me darken it up a little bit. Go back to our histogram. This is, and Daryl, I gotta tell you, this is the kind of thing that I really love about what we've built here. We can actually show people these objects basically seconds from when we take them, and almost exactly like they're gonna be seen when they look at the finished processed image.
Uh-huh.
I like that.
Oh, yeah.
Look at that. Look at this. Wow.
You've come light years in your processing, too.
Yeah,
So.
and that's true. And I love passing it on. I mean, we look at Izabela, Melamed from Sofia, Bulgaria. She has taken our images and done her own processing on them, and they're just stunning. She just knocks our socks off with what she does as well. I have to share with her my, what you say, my light years ahead. I have to share with her my processing techniques so she can do it too. Because I made them into like little programs within Photoshop. You can just click a button and they do about 30 or 50 things to get the image to look good. And you got to use it with intelligence, right? And that's kind of cool. I think the
Well,
processing
that's-
is the most important part, yeah?
Experience is the difference between knowledge and wisdom.
Yeah, that's right. That's right. Everybody knows how to drive a car, but until they get in that car and slip on the ice for the first time, they don't know how to handle it.
Oh,
Look at
God.
this, guys. What?
Don't get me started.
Oh.
Oh, we
Winter
got so
drivers?
many flatlanders that have moved here to Colorado. It happens every winter, but I mean, I'm over at the local subreddits, Colorado Springs and stuff, and
Yeah.
some guy posted today, "Oh, I just moved here from down south, and I don't know the first thing about driving in the snow, but I've got to go to Denver International Airport to pick up some friends. Tell me how to get there on one piece."
Take an Uber.
That was suggested. I told him to get in the right-hand lane and stay there. That always upsets some people because I think they have some God-given right to drive in the left-hand lane.
Yeah, and we actually have a law here in the country, in our state, which says that you can't drive in the left-hand lane if you just want to drive. You actually have to move over, and that's only used to pass cars that are moving slower in the other lane.
Same thing here.
Oh, okay. I didn't know
Yep.
that. That's cool.
If you drive up mountain roads here and you
Yeah.
hit a hill or you're on a pass,
Yeah.
you will see signs saying slower traffic, keep right, and keep right except to pass.
Yeah, we see that.
And some people get it and a lot of people don't. They used to not ticket people for it, and now they are.
Yep. Same here.
I say good.
Yeah. Because you don't do that.
Well, I will pass when necessary, then I get back over in the middle or right-hand lane.
Yeah. That's right.
Actually, my driving would probably scare you. I learned, this is my 46th winter in Colorado, and I cut my teeth on winter driving 8 years up in the high country, ski areas and stuff, dealing with hundreds of inches of snow a year, and not to brag, but I can drive well in winter conditions, knock on wood. And I would doubtless scare some people, but I have a good seat of the pants feel for my car and what it'll do and whether it's hooking up or not. And I don't exceed that. But I often use the example of a guy I saw some years ago during morning rush hour during a snowstorm. He was from New Jersey. He was driving a BMW. He was going 5 miles an hour in the left-hand lane.
Eek.
And he was white-knuckling that thing all the way. He couldn't figure out why everybody was passing him on the right and honking at him, and he was freaking out.
Yeah, see, once you get into that mode, panic sets in, and you don't see anything anymore.
Yeah.
But I do want to answer Charles Smar's question. Charles is asking about the Lagrange points. As you guys know, the James Webb Space Telescope has launched. We actually streamed it on Christmas morning. And you see, the James Webb took precedent over opening presents around here. How about that? That's dedication.
Same here.
I'm the only one, though, that saw it that way. But that said, the Lagrange points, there's 5 of them. We have 3 that are aligned with the sun and the earth, basically. Okay, we have L1, L3, all right, and then L2 beyond the moon. So it's L1, L3, and L2. And then we have L4 and L5 that are in the Earth's orbit. Now, the L4 and the L5 positions, if you can put a spacecraft there, it'll stay there. It doesn't need any outside force. It's a stable Lagrange point. Lagrange points, in short, are parking spots in space. Really, that's what they are. They're like parking spots, right? But L1, L3, and L2 are what are called metastable. So they need a little bit of assistance, but they can stay there as long as you have the object you want moving in sort of an elliptical orbit where you can absorb some of the idiosyncratic motion that nearby gravity could could impart. But the metastable L2 position is where the James Webb is going. And they couldn't put it at L4 and L5, which need no additional assistance, unfortunately, because at that position, they'll limit what they can see greatly, because you have the sun in one direction, and then just like 60 degrees or more away, 80 degrees or more, actually between 60 and 80, you're going to have the Earth in the other direction. And that's going to limit a lot of what you can see. So L2 is, past the Earth, past the moon. It's about 1 million miles from here. And at that location, it has enough fuel for about 10 years. And by then, I think we're going to discover ways to refuel it. In fact, I know I've said this before, and Daryl knows this. I watched the refueling operation in the laboratory, which showed them refueling a satellite in the lab that wasn't meant to be refueled autonomously by a robot. And they did it. They actually taught a robot how to do it. And because they can do that, I know what they're going to do. They're going to do that for the James Webb. That's what this is all about. It's got 18 mirrors, and it's 100 times more powerful than the Hubble. You're darn right we're going to try and make it last. And the nearest thing to the James Webb, actually, was a telescope that was much smaller than the Hubble, and that was the Spitzer Space Telescope. Its mirror was less than 3 feet in diameter, okay? And that mirror showed us views of the universe that were just unparalleled. And now we're putting up something that's 21 feet in diameter. And those germanium is the element that the mirrors are made of. Germanium is very stable and so forth. If you drop it on the floor, it'll smash like glass, but it's extremely hard to move it. You can do a lot of motion with it, and nothing will happen to it, which is why it's a good choice for the space telescope.
I thought they were made from beryllium.
Beryllium, I'm sorry. I apologize. Thank you. They're beryllium mirrors. All the same things apply. I don't know why I said germanium. Whatever.
Sorry.
Thank you. I spaced on that. No pun intended. But they're covered with gold because gold, it's a very, very fine vapor deposited gold coating. Gold is not very good at transmitting or reflecting a lot of the frequencies of light. Hence its color. It's a golden color because it's only reflecting the colors that are not in the blue end of the spectrum. But gold is also good at reflecting all the colors that are farther out into the infrared, which is exactly what the James Webb Space Telescope mirrors have to reflect. And the gold is also good because the gold is not subject to cosmic ray and gamma ray degradation from other sources of damage, right? Yes, micrometeorites can pit them, and they will, without a doubt. But they won't outright smash them unless it's something the size of this, okay? I mean, if something like that hits it, it's a goner. It depends on the speed. If it just goes tink, then it won't do anything. But you know what I mean. Anyway, we've been stacking, by the way, just so you know. This image here that you see right there is a stacked image of Messier 33. Messier 33 is the Triangulum Galaxy. There's the label for you again. And the thing about this galaxy is that it's around 2.7 million light years away. I have to look that up. I think it was Andromeda is like 2.4, is it not?
Andromeda is about 2.5. Yeah. I've heard numbers vary for M33. Yeah, somewhere between what you said and 3 million light years.
Yeah.
It is not physically far from M31, though. They're in the same neighborhood.
Yeah, which could explain why we see what's going on in Messier 33. When we look at it up close, okay, which is something we're doing live. All right, this is a live up-close view. This is not a photograph. It's a live view. And when we look, we see many convoluted things going on in here. Look at this nebula right here, Daryl.
Uh-huh.
That looks like a massive supernova remnant. There's one here, too. There's one here. The green ones are also supernova remnants as well. Just astonishing. And then you see this gigantic nebula. What's this? This is 604, correct? NGC 604?
Yes, it is.
604 is a giant star-forming region, an emission nebula, and a stellar nursery. The nearest competitor in our galaxy to this would be something like the Eta Carina Nebula, probably. And then you see some tiny red dots here, like these guys, all right? These tiniest of, well, you know what? Why don't we zoom in so you can see them? So if we get closer to this now, look at the fibrous nature, the tendrils. Okay, but if you look at these little tiny red objects, these are also stellar nurseries in this galaxy. And one of the things that's interesting is an equivalent to something like, say, this one right here might be the Orion Nebula in our galaxy. But the Orion Nebula looks huge in the sky. That's because it's close to us. This is 2.7 million light years away. It's way out there. So it's going to be a lot smaller, you know. Satisfying Animations asks, Mark, have you ever considered using narrowband filters? I have used narrowband filters. The only problem, Satisfying, is that, and I'll get to your question, Ufi, thank you. The only problem, Satisfying, is that the narrowband filters require a filter wheel, and the way this system is set up, we're shooting with a telescope that has been reduced in its F ratio from F8 to F2. Now, what's that mean? It means that it's a very fast, wide-angle telescope. This view looks like a lava lamp exploded. That's good. Okay, this view we're seeing right here is more than 2 degrees across and more than 1.5 degrees tall. That's 4 full moons across and 3 full moons tall. All right, so that's what we're seeing here. And if I were to put the filter wheel, which I considered on this system, it would end up being on the front of the telescope, not the back. Because this camera is off the front of the telescope, not on the back. It's a really interesting configuration, one that I thought about years ago and said, I'll never do that. What a silly concept. And look at the results. I mean, I've eaten crow on that, and I accept it, you know. So, but narrowband filters, for those that don't know, narrowband filters are filters that you basically allow in only a small amount of a certain kind of light. Okay, these objects here that we're talking about here, these hydrogen emission regions, these are hydrogen alpha, and there's a narrowband hydrogen alpha filter. So that light from those things would come in. Then you have an oxygen filter that would bring in these green objects here. Okay, because these are the primary component of nebula, are hydrogen, oxygen, and we also have hydrogen beta, and we also have sulfur. And if we were to take a narrowband image of this galaxy would look very different from what we see here now. Okay, it might not look too exciting to a lot of people. They might say, "Well, what happened to that?" And, you know, but we're showing it in its natural colors, and we have a balanced set of narrowband filters all combined into one. That's what takes these images. Effectively, they are narrowband, but they're all combined as one, and that allows us to see everything at once.
Yeah.
If we have to combine the narrowband images, that's a process. And I don't want to see people sitting through waiting for these to be combined. So it's all about immediate satisfaction.
Yeah, narrowband filters don't really work well on galaxies because galaxies have such broad range of different wavelengths of light. narrowband filters work well on emission nebulas and supernova remnants and stuff like that.
Yep.
Uh,
You got to pick your
as
poison.
Yeah, as you probably already said, I mean, when you were running this scope at f8 or the old one at f10, you had a filter wheel on it with a variety of narrowband filters.
Yep.
But now that you're stuck with the camera on the front of the telescope, you can only put in one filter because it's remote, and so what you have is sort of a light pollution filter, isn't it?
Oh no, it's way beyond the light pollution filter. This is actually the LHC UHCS filter. So basically, it has a path band for the H alpha, has a band for the silicon, has a band for the oxygen 3, and then there's a little bit more let in. And those are all in one filter. So it's like all three narrowband filters combined into one, with some additional for like the additional there's fringe frequencies that are allowed to come in as well along either side of those. So it really does a lot, and it does get rid of a lot of the light pollution in general. That's what it was for. I did have an ordinary light pollution filter. It's actually down in a box right here, and I have not utilized that. This is all just a straight UHCS filter, which is
okay.
Yeah, it's a
I knew
tri-band
that.
filter.
Forgot.
That's all right.
We've been through
That's
this
right.
before.
Yeah, that's okay. All right,
So
so we've done 40 exposures here.
It is seeing not just the narrow bands of like H2 and O3 though. I mean, it's showing you everything, but it's accentuating the H2 and the O3.
That's correct. If you were to actually, like, the O3 is the green stuff, guys. The oxygen glows in this green, and the hydrogen alpha glows in this red. The galaxy is full of hot blue stars, and those blue wavelengths are allowed through the filter, obviously, because we can see them. So this is sort of a general purpose filter that works very well for almost every object we look at. You know, and Izabela's here. Hello, Izabela.
Farva's here too.
Oh, Farva. Hey, how you doing, man? I haven't seen you in a while. Papa Tom, good to see you. This is great. This is a wonderful New Year's Day. Lots of good people here with us tonight. So that's really nice. Nice to see you all here. And so what we're going to do is we're going to take and go to... Oh, you missed what I did, by the way. I saved this. So right now, as we speak, this image and the saved stack, Ufi mentioned it in the chat earlier. I saw that, Ufi. That saved stack of images is in a format called FITS, F-I-T-S. It's an astronomical image format, but you don't have to worry about that if you just want nice, pretty pictures, because you can take, you go to our website, not our website, but our live server, which is free to go into and take anything you want. I don't know if Daryl got a chance to put that address
I
up
did
there.
earlier.
Okay,
I
great.
did. I
Okay.
closed the window. I posted it again.
Okay. And, well, Isabella's here, so she'll probably post the link for us, too. Hi, Jessica S. Happy New Year to you, too. Thank you. So, the thing is, this... I'm an astronomer, see, so sometimes my train of thought goes from object to object. I'm doing 5 things at once here. So sometimes I forget what I was doing one moment to the next. But as Yuffie had said something I was trying to respond to. I think Yuffie said about the server. As soon as the photographs are taken, they go up to the server. And I don't have to send them. Oh, there it is right there. Thank you, Daryl. So when you go up there, you'll see today's date, and then you wade through, and you'll see, if you don't want to play with the astronomical image format file that we mentioned, the FITS, then what you can do is you can go play with the just the ping file, which is just a graphic file. Okay, and that file is one that you would probably be better served with if you don't want to mess with image formats. Okay, and that's the kind of thing that I think is what you'd probably rather mess with. Okay, and that'll be up there. Thank you, Leslie. Wow, fantastic. Yeah, what Izabela said. Yeah, I hope it's a great year. I mean, we have lots of things that we're adding to our repertoire here, so hopefully we'll be able to do that. So let me do this. We're going to close this stack. This image has been saved. It's up there, so we can get rid of it and come back into here. This is our camera controls, remember? And I'm going to change our exposure down to 1 second again. All right, and the 1 second exposure. I mean, if you think about it, that's pretty cool. Okay, when you come in here and you actually do our hybrid view, right, and you can see the galaxy with a 1 second exposure. That's not bad. Hey, Ronald, ERRT Radio, you've been here for a while. I didn't say anything. I apologize. So now, let's go back. The focus has been good tonight so far, Daryl. We haven't had to change it.
Mm-hmm.
I'm going to take us up to the Andromeda Galaxy because
I knew it.
No reason not to.
Sure.
It's right there. So I told the telescope now to go up to the Andromeda Galaxy. You can see it over my head. It's going to move now. There it goes. You see the stars mimicking the movement. And it's going to put a bright star in the view, namely Mirach. That's this star right here. It's going to center it right about here, just below in the lower third. And then it's going to head off to the Andromeda Galaxy, which you'll see as that faint spot, which is going to come into view really quickly here. And I'm taken aback every time we do this. I just have to keep saying over and over, this is 2,500 miles away. It's 2,500 miles away. And I just sometimes can't believe it. You know, it's so cool, so effective, and everything that I did to make it happen was just on a whim of trying to get this to work. All right, let's bring the Andromeda Galaxy into view here.
I still want my flying car, darn it.
You know what? I know, and you know what? There are some flying cars going on the market. Did you see that?
Yeah.
Now we're going to move a little eastward. Center it up. Then we have to wait about 14 seconds, and that's for the telescope to get a guide star. This is just my observatory control program that I wrote, and I just keep it off to the side here. I always keep it nearby in case of accidents. All right, so here's the Andromeda Galaxy, and we should have our guide star by now. If you haven't seen this galaxy in this telescope, you're in for a real treat. And if you have seen it, you're in for another treat. Okay, so let's go over here and let's change our time to 30 seconds again and get rid of the hybrid view. Think of the hybrid view as sort of like a night vision shot of the area of the sky we're looking at. All right, now we're going to go into the live stack here. Stacking is paused. Let's clear this stack. And then say resume. Oops, it was automatically resuming. Okay. Okay, so the stack is reset, and we'll see the first view of the Andromeda Galaxy in the new year. 2.4 million light years away or so. Look at that. Wow. Oof. Yeah, that's beautiful.
Yep. And there's actually 3 galaxies in that image right there.
Yeah, let
The
me bring it
round
back
one,
in so you can say that.
yeah. The round one below center on M31, that's M32,
Hmm.
and the one to the upper right is M110.
Yep. And of course, this is Messier 31,
Yes.
the great Andromeda Galaxy. And I want to show you something right now. I'm gonna zoom in. I'm gonna go to 100%. This is how big the sensor really is. Okay, I'm showing you reduced sizes. Okay, you see all this graininess and coloring. This is called noise. It's image noise, and this image noise is gonna go away. You see this? Watch what happens now as this next exposure comes through. Watch the noise. Boom. See how it got reduced a little bit? That's going to add up, and over time, we're going to lose all the noise in this image, and it's going to be beautiful. Yeah, so now let's take us down to just fitting it to the screen. There it is. And now let's go into the stack, and let's set the color, see if the color correction is required. A little bit, and then let's do an adjustment to the overall look. Okay, and now let's lock this in, and there it goes. Let's lock it in for real, and then let's just maximize this view, because why not? That's really pretty. This is just such a beautiful galaxy. And you're going to see it in about 2.5 billion years. Because it's going to collide with our galaxy. The Andromeda Galaxy is heading for us. Most likely, they're going to pass through each other. And that'll forever change what our galaxy looks like. This galaxy here has about 1 trillion stars in it, compared to our 150 billion, 250 billion. So that means that this galaxy has more mass, and it's going to be the one to do the most damage to us. But I say damage, and the inhabitants on this planet at that time won't even notice it. They won't even notice anything. Because the stars are so far apart, they're going to pass through each other. Kind of like two liquids mixing, you know, except they have gravity. And so our galaxy's barred spiral shape, where it has a extended center section here and spiral arms, okay, that's our galaxy, will be altered when this galaxy passes through it. And it's going to tug on our spiral arms, it's going to pull us out of shape, and our galaxy will no longer look like it does now. So that's going to be kind of cool. Go away. Isn't that something? That's really pretty. I went up a little north over here, Darrow, because I realized the northern edges aren't visible, but I wanted to really highlight this area.
Oh yeah, I don't blame you.
I'm gonna drill into this for a minute now.
You know, we've talked about that area on the lower right before.
Yes, we have.
Thank you, Farva.
Thank you, Farva.
OB
I'm glad you
associations,
saw.
aren't they?
Yeah. There's
a
this
particularly bright spot anyway. Yeah, like that.
Yeah, here, and up top as well. And interesting, you know, we talked about the Orion Nebula and the other nebulae in Messier 33, but check this out, okay? We have right here, we have another nebula. Where is it? Where'd it go? Right here. Okay, this nebula right here, look at that. That's a beautiful nebula. That's 2.4 or so million light years away. Light years away. So that, with its associated nebulous detail, this is probably a star-forming region. We've got one over here. We have one there. Everywhere you look here, you see them. Okay, there are a lot of places that they are in this galaxy. All right, and let's see if we can go check one out at the other end here. Yeah, right there. Look at that big one. That's extensive. It's pretty extensive. Yeah. And let's bring that over a little more. Wow. Yeah. Okay. And at this end, more nebula, more star-forming regions there, here, there. They're all sizes. These are the places where the stars are born, and sometimes they give birth to massive, giant clusters of very hot stars, like this one, like this one. These are the spiral arms. This is the realm where these massive stars form. And what these were beforehand were gas and this dark material. These are called dark nebulae. These dark nebulae, these gases, they're throughout the galaxy. It's mostly hydrogen, and it's mostly dark dust created in supernovae. All right, and this dark dust that we see is composed of carbon atoms. It's composed of other compounds created by carbon atoms. In addition, there's ammonia ices and a lot of ice of different types in here, methane ice, ammonia ice. Okay, and those are parts of these dark dust, and it's going to be really interesting to see how this progresses over time. You know, and we look at the galaxy, you can see that this dust seems to be confined to the spiral arms, doesn't it? Yeah, and it is. You know, see, there's some here, there's some there, there's some there. It goes around, all right? It cuts through here. It's everywhere. But that's just something. That's a beautiful, beautiful view of this galaxy.
I read something recently. They said that they is in Andromeda. I'm almost positive.
Okay.
They found another very large black hole, but not at the center of the galaxy. It's like to the right, to the upper right of where we see the nucleus.
Okay. Well, that could be the result of interactions with Messier 33, say.
Mm-hmm.
And that black hole can be moved, you know. Curtis, hey, how you doing? Curtis Horn is here. If you know Curtis, he's a figurehead over at cloudynights.com, the most amazing website. In fact, they were instrumental in helping answer questions I had, looking for hardware ideas for the observatory. So that's wonderful. Skunk Ape here is here now. That's good. Good to see you, man. And Yuffie says, is there a way to estimate the number of red dwarf stars in our galaxy? I guess when we monitor stellar populations, Yuffie, we can do that. We can figure out how many we suspect are there, but we can't give an exact answer. We do know they're the most populous star in the galaxy. There's more of them than any other kind. There's more planets around these types of stars than any other kind. That's just so cool. But unfortunately, with these stars, they're so small, sometimes being only slightly larger than the planet Jupiter, that to talk about them with their planets and the retinue of planets that go around them, it's easier to talk about Jupiter and its moons rather than to talk about this star as compared to the sun, because it might be 100th of the mass of the sun. It might be a lot smaller in size, and so it has to be 80 times the mass of Jupiter to just be the smallest of stars. That doesn't mean it has to be big. Okay, the point I'm making is that if you look at how dense a star is in its core, it has to be dense to reach that initial 13 million Kelvin in order to start nuclear fusion. And to do that, it's also going to be very compact. So it stood to reason that we might find a star smaller than Jupiter, but that was massive to be a red dwarf, and we have found that star. There's many of them. And if they have planets around them, now you see why it makes more sense to talk about Jupiter and its moons rather than the sun and its planets when comparing it to that. So that's pretty interesting. Let's see. Anahana says, why is the center of this galaxy so much larger and brighter than most we view? Well, this one has a lot of older stars in the center, Bonnie. And so if we take a longer time exposure, then we're going to see the galaxy has a bright core. But guess what? Every galaxy we photograph has a brighter core. The stars are denser. Okay? Let me read here. Curtis writes, so I'm putting together the January 2022 Electronic Assisted Astronomy Objects of the Month. Marc, do you have suggestions for the list? Oh boy, I think Daryl and I both do. Yes, and the JWST is a great one. That was one that we want to look for as well.
Yeah, it's in Orion now.
It was, yeah, and we should be able to see it. If we knew where it is, we'll take some deep exposures and see if we could actually see the James Webb Space Telescope tonight, if we can get to it. We'll make a point of it.
A lot of people.
And now's the time to do it, huh?
A lot of people have been tracking it, imaging it.
Yeah. Are you able to get the right ascension and declination for
it? Give me a moment.
I gave Daryl something hard to do, I think. It's not hard. And actually, maybe the Sky Live has it, Daryl.
I know he mentioned the JPL Horizon site.
Okay. This is nice. All right, how many have we done? We've done 25 here. So we're going to pause this for now. And we'll save it. And now you'll see across the top of the view there, you see that green bar? That's the FITS file. It says it's been saved to our special directory. That's a holding zone. And then, boom, it's sending it up to the live server for you to check out. And then we're going to save this exactly as you see it here. Okay? So you'll get a beautiful photo right off the bat that you can take down and view and enjoy and examine. And you know what? We've taken so many photos of these different things that guess what? It's possible that there's a new discovery lurking in there. Maybe a supernova. So by comparing the previous image with a new image, you might be able to see that, you know? And then if you did find one, you get credit for it. I think that's pretty cool. Okay, now we're going to get out of this stack here. We're going to clear it first. All right, and then I'll go back and let's go now to 1 second. So I hope I answered your question, Bonnie. If I didn't quite do it adequately, slap me around a bit. Jessica S., I want a telescope and a microscope for Christmas. You know what? You're so funny. I did the same thing, Jess. I actually asked for a microscope for one Christmas and a telescope for the next. Well, for my birthday, I wanted the microscope, and then for Christmas, I wanted the telescope. And my birthday's in October, so I only had to wait till December. But it just didn't work out, you know, to get both in 1 year like that. So I didn't get the microscope, but I did have a very sympathetic teacher in school, Mr. LaFrance, and he let me take home a big laboratory microscope for the summer. Taught me how to use it, and I spent the summer just zipping through inner space like you couldn't believe. It was so cool. It's a universe unto itself, you know. I learned so much about the inner workings of nature and the world by watching these little ciliated paramecia running around. and other flagellates that are just using this one tail whipping around. It's just amazing stuff. Very cool stuff. Okay. Let's see here. Let me move this over a little bit. There we go. All right. Let's get out of this full screen here. I want to see my telescope view again. Ba-doom. Now we're back. And now bring this back up here. Okay, it'll come up. And then what we're going to do now is we're going to go back to our planetarium program. We checked out those guys, and now what I'd like to do is take us to something else. I think that gotta just check. No, I think we're
good. Well, I have the page. It's going to take a little studying to figure it out.
Okay, no problem, because I'm going to take us to the heart. It's time to blow people's minds by looking at the Heart Nebula. So here we go. Okay, the telescope is going to start moving. Okay, there it goes. What's interesting as it moves, you see the color of the stars. Look at all the different colors. Okay.
Skunk, Arcturus is not visible this time of night. You'd have to wait till the morning sky before it comes up.
I do like what he calls it. Sky Eye Peeker Thingamabob. I like that. This is the SkyTour live stream Sky Eye Peeker Thingamabob. That's pretty good. That's very cool. Okay, so now we're going to the Heart Nebula. You'll notice this reddish thing in here. This is a beautiful nebula, and I can't tell you how much I enjoy this nebula. It's beautiful. There's some up here, there's some down below. It takes up way more than the amount of the size of the sensor. So it's not like we can see it all in one shot. So we just have to pick our poison. So I'm going to pick this right here. That was if it found this at a good spot. So I'm going to take us back to a 30-second exposure of the Heart Nebula. And we're just going to need another hour or two, I think, before we can start looking at the Orion wonders. I could be wrong, but I'll try it. But anyway, let's auto size this because it's all in here. I just want to drop this out. Yeah, there's the fish head. So this is the whole Heart Nebula. All right, and what I'll do is I'm just going to move us a little bit over this way. Oh, did I already change the... I did. Sorry. I'm going to get a strange view here. Okay. Alright. There we go. Okay. So that's 1 second. So what I have to do is move us over just a little bit. There we are. And let's just drop south a little bit just to pull in more of it. Yeah, because I want to get these stars down here. Okay. So now, let's go back and do that again. This time, we're going to do 30 seconds again. And then we're going to drop out of our hypered view and do our 30-second and start the stack. Make sure you do hit the thumbs up, okay? and like us. Doing that helps us so much with the metrics on YouTube. This is great. What do you think, Daryl?
I'm still trying to figure this out.
Okay.
I haven't got to look yet.
All right. Oh, look at that. Let's just do this. Let's get the stack up here. Let's make sure that I know the color's good, and that's actually good for now. So we're just gonna pin this in here for now, and then we're going to get out of this, let it go to that, and then we'll just maximize it. Let's fill the screen because we can. Look at that. Wow. Look at this nebula. This is just so beautiful. Yuffie, that's no offense taken. I don't know of anyone that does remote viewing. Believe it or not, I actually dabbled with that for several years, and I was okay. I was above the statistical expectation, but I did run some labs that actually showed that it worked. And I did an experiment, a double-blind experiment with two people, and one of the other people in the other closed room saw the image of the person in the other room saw exactly, got it exact, and I came up with the image. Okay, they had no idea what it was going to be, and I thought that was pretty cool. And hey, David. David Schmidt is here. He's from the Bangkok area. Oh, sorry, Curtis. I know what you're getting at. I should have mentioned it. You put in Caldwell 5 and JWST. Sorry to make you type that again. I was actually trying to find the coordinates of the JWST, and I kind of got sidetracked. I apologize. Well, I mean, I can tell you right now, it never fails to look stunning, and that's the elephant's trunk. NGC 7822 is good in terms of all the amazing dark nebula and Bach globules that are there. We also have some of the dark nebula that are really interesting that are in this region. A lot of the LINS from the LDN catalog, LINS Dark Nebula catalog, those requires dark sky sight. I mean, we can see them here. I don't know where that would. It might not be a big hit though if people don't get to see them, Curtis. So the dark nebula would be tough, you know.
Monkey Head.
And Monkey Head is also another good one, yes.
Yeah, that impressed me recently.
I see Curtis says you can find JWST using the Horizons JPL site. That's
easier said than done. That's what I've been trying to do for the last 15 minutes. I enter the terms the way they say to, and it says error. I'm not in the habit of looking up ephemerides or whatever it's called.
Yeah. Wow. David, you're in Khon Kaen? Is it Khon Kaen? Northeast part of the country, so you're not down in Bangkok anymore. Okay, fantastic. Excellent. Are you still teaching? Legless Lex, how you doing? This music is perfect for this.
Mark, excuse me a moment, please.
Sure thing. Yes, I'm actually quite familiar with quantum entanglement, Jessica. She says quantum entanglement on remote viewing. Quantum entanglement is actually going to be tomorrow's cell phone. Now, what do I mean by that? I stood in front of 800 people at a conference, and I asked a question. I said, raise your hands. How many of you thought of a person you haven't talked to in 10 or 20 years, and the phone rings and it's that person? Sounds like a stupid question to all of you listening. And every hand went up, and of course everybody starts to laugh. And then I said, science would have you feel and have you believe that's coincidence. It's not coincidence. Look around. This type of coincidence then occurs all the time, all over the place, every day. There's something more to it, and just because science can't penetrate that veil yet, they can't say it's just coincidence. To be fair, they should be saying it's something we may not understand. You know? So, that's what I believe. And I do feel that quantum entanglement between humans occurs, and I've mentioned this many times. I made up a word. I call it the brainular level. Okay, we connect to humans. Same matter, effectively, in our heads. And so therefore we connect that way. So remote viewing is just a way of you to process what the other person sees through their eyes. Right? And I think that's one way to do it. All right. Now, there are people that say they can remote view without anyone present. They just send themselves there. Well, that's possible too. Maybe. I know that I tried that and it wasn't nearly as successful as when I did it with another person. Seeing through their eyes. I actually called it becoming them. So I'd say, I'm going to become you and see what you see. And that was pretty successful. I actually did it with someone 3,000 miles across the country. And as I recall, it was pretty accurate describing this place. To me, that just says this is just undiscovered science. All right. So today's paranormal will probably be, in many cases, tomorrow's science, and I do believe that. And this Heart Nebula is astonishing, isn't it? Look at this detail. Look at this area right here. Look at all that beautiful dark nebula. That's beautiful dark nebula up there, you know. And maybe what we should do is zoom in on that little area. There we go. Oh, look at this. Look at this. Ah. You see, this is why I do this, guys. Look at this. Look at this beautiful, complex knot of dust and glowing hydrogen gas made to glow by these hot young stars in here. Okay, there's also dark dust in there as well, giving it that shape in part. Look at this filamentary structure, this beautiful filament of nebula here. This is something that just a few years ago I just literally had no hope of ever seeing. You know, but there it is.
That's very nice.
Isn't that beautiful, Daryl?
It is.
Look at this. Let's get even closer. It's like we're going to go into the nebula now. Wow! And look at that. It's so beautiful. Head over a little bit more to this side. So you can see this is dark dust. And where did it come from? It came from countless supernovas, you know? And that is really interesting, you know. Countless supernovas left this dark dust behind. And they also spewed a lot of the hydrogen gas back into the interstellar medium that you see here. The complexity is caused by all the many gravitational forces tugging and pulling on this material all throughout the region. You know, so I think it's just something else, you know. Let's see, and I have a question from David Schmidt. How much of a temperature changes are in the differently colored region? Okay, very good question. How much of a temperature change is there in the differently colored regions? Well, The hydrogen gas ionizes because of ultraviolet radiation. The ultraviolet radiation that causes the hydrogen electron to bounce off the hydrogen atom in interstellar space is a fairly high, what we'd call a temperature, right? But there is no temperature in space per se. There's only absorption and radiation in space. But the gas is heated up because they're particles, all right? So they do get very hot. The dark nebula, on the other hand, is dust grains that may be close to absolute zero in some places. Certainly not in this region, for instance, because there's a lot of additional radiation striking this dust, heating it up. And the way to tell is to hit this with an infrared system like the James Webb telescope. If we looked at this nebula, the Heart Nebula, with the James Webb, we would see in this dark nebula region here, we might see stars by the dozens forming in here right now. Okay? We might just see that. We might find some of these Herbig-Haro objects, which are the objects that are created by young protostars before they actually can actually get very far along in their lifespan. So there's a lot of amazing things going on in the universe. And I have to say again, this music is perfect for this. It's like wow music. I know you can't hear it, Daryl, but it had to be that way so you could actually be sane throughout this.
Yeah, so it goes.
So we back out of the Heart Nebula in the core of the matter here. And now look at... Yeah.
Curtis, per your statement in chat, I am not making any headway at the JPL Horizon site.
Okay. I haven't looked at it yet either. Wow. Okay, how many do we have? We have stacked 24 of these. Alright, so we're going to pause this now. And save it. When I save it, it's going to start racing up to our live server, which the link has been put into the chat multiple times. And then we'll save the picture just as you see it here, so that you can just go look at a gorgeous photo if you like. I will further process these to show you even more later. Alright, so, but now we're done with this object, and we're going to do that and get rid of it. And you say, why'd you do that? Because I saved it. You'll see it again. And now, let's go down to 1 second again, and we're going to take ourselves over to another object right near it. And I know you know what that is, Daryl.
The Soul?
You got it. Hey, if we're going to do Heart, we should do Soul. The Heart and Soul.
Sure.
You know? Okay. And there's a number of other nebulae that are inside of each of these nebulae. Okay? So that's something that we look at too. Okay, so here is the one we're going to go to. And away we go. Okay, the telescope should be moving over there. Let's get out of this for now. There it goes. Telescope's in motion. Let's see it up there. And we're going to go into our hyper view so you can see all the many stars that are in this view. This will probably be our guide star that's going to guide us until morning to see the Soul Nebula. And it's going to be auto-centered, and then it's going to go to the Soul Nebula. Oh, and there it is. Curtis, thank you. That's a great idea. Use Arizona. You can use Phoenix, Arizona. It won't be that different because we have a 2-degree field. All right, look at this. So now let's check this out. All right, we're gonna just drop down. Okay. All right. This has been a good night so far, Daryl.
Yeah. I'm not having any luck with the JPL Horizons thing. Perhaps
well,
Curtis could. Yes, I see that. I heard.
Okay. Curtis is going to try and find us the James Webb Space Telescope. Look up. Oh, we should be able to see it leaving a trail if we do a deep exposure. And that's kind of what we're looking for. Okay. The big dog. What's going on, brother? Good to see you. Okay. Alright, so now we're going to go in here. Go to 30 seconds again. And we can go for many minutes per exposure, but we can get something with that, but I don't want you guys to have to sit through that. So we're just going to do it at 30-second shots with a very sensitive camera. No, we've got a lot going on here with this camera. This is pretty good. This camera is one of the best dedicated astronomical cameras that are out there. And we're very, very pleased with this camera. Alright. So you can see the green progress bar. We'll see our first image here. Ready? And boom. Ah, oh. Wow. Wowee. What do you think of that? And again, just to point out real quick, I'm going to do this again for you. We're going to go to 100% of the size. I want you to notice the noise. See this looks kind of awful, this noisiness. That's one shot. Let's now add one. Ready? Watch this. Boom. See how much better it got? That's the benefit of stacking. We're creating image layers, layer upon layer upon layer of the same image over and over. That noise in the background there gets wiped out over time. And it leaves us with a gorgeous image. That's what stacking is all about, and that's what we're doing here. So, we can go here and enjoy the Soul Nebula. Here it is. Okay, bring that back. Okay. And now, let's go and maximize, or I should say, fill the screen. Oh, look at that. Interesting. There's a little tiny nebula down here that I haven't seen, right here.
I think last time we looked at this, I called this the Mae West Nebula.
Like here and here?
Yes, but what it is, I see the star baby. We've talked about this before.
Oh,
the
yeah,
star
right here.
child.
There's the mouth.
2001, yeah.
The
his
eyes,
head's on the left, his body on the
hands.
right.
Yeah, that's right. That's the star child.
Yep.
Actually, that's a better approximation, I think.
Yeah. I guess I was in a randy mood when I said Mae West the other night.
Oh, it's okay.
I called it the bikini top or something.
Yeah, you did. It's hilarious.
But that's the star baby.
Mm-hmm. Let me check something out here. This is neat. Let me go in here. Okay.
Curtis posted the.
Oh, I see. He posted the coordinates.
Yeah, the ephemeris for. Now we may have to update the time by whatever time we get Orion in view.
Yeah, but
Still fairly early.
with 2 degrees, it's been in Orion for days.
Yes.
So we'll still see it. Did you actually copy down his coordinates? I didn't do it yet.
Give me just a moment, I will.
Okay. So that'd be kind of fun to see the James Webb Space Telescope tonight if we could. I mean, from where we are, there should be no reason we can't. I mean, we've easily found magnitude 17 geosynchronous satellites. Wow, this is really pretty. Wow, look at this guy right here. Okay, let's just pull right in here. Look at this. Look at this area. This dark nebula right here. These isolated little black blobs. When they're isolated, they're called Bok globules. Bok, B-O-K, discovered these. And they're really fascinating little globules. They point to star or planetary formation. Wow. After we do this, we'll see where Orion is relative to us. Charles says, Yuffie, Tori, math is a good guide, but then I remember that 90% of the universe is dark matter and energy. Yeah, it's that percentage changes depending on who you talk to, but it's like 96% of the universe is stuff that we don't know. We know 4% of the universe. That other 96% we don't know. So I think that's a pretty good indicator that there's a lot going on in the universe we don't understand. This is beautiful. This nebula never fails to just give me amazing views. Let's do this, see if we have any difference. Yeah, see, a little color change there that would give the colors more accurate. That's more correct colors. Beautiful reds.
Yeah.
What? What'd you say?
I said, bleh.
You don't like it?
No, that's great. I had a slight taste problem here.
Oh, okay.
Personal problem.
So you notice these pillars here. Remember the pillars of creation in the Eagle Nebula? Hubble took pictures of those. Well, those pillars seem to be something that is related to star formation and what happens after the stars form they tend to make pillars like this one here, okay, like that little one right there, like that one, that little bud sticking there. And what that is the stellar energies impacting the dust and the gas that's in this region. And so if there is an area that that happens to be in this region of space that has a denser composition, like it's compressing under its own mass, maybe to form a star sometime or a planet sometime, then this area at the front end is going to be denser naturally, and then the stellar radiation striking it will clear away all the dust and gas around it, but leave that, and then in the wake of this object you're going to get like this stalk left behind because the evaporation occurs all around it. I say evaporation is the stellar energy pushing the dust and gas away, right? And so that happens there, that happens here perhaps, that happens here, and in multiple cases within little areas here. So, and where would that happen from? Well, if we go up a little farther, we can see a young hot star cluster in the middle of the Soul Nebula here. And that star cluster could be sending this energy down here to cause this. We don't know whether this object over here is actually like this, angled away from us, or angled this way, or just flat to us. Okay, it could be deeper in the nebula aiming toward the star. It could be out of the nebula aiming back toward the stars. We don't know. It's a physical, geometric, in space number that we just don't have for things like this. But it's pretty. That we can all agree on. So I'm hoping that all of you are going to have a good, happy new year in 2022 here. Yeah, we got lots to do tonight. Hopefully we can do that. Legless, thanks for stopping by. We'll see you when you come back in. Alright, Daryl, you got the coordinates. Pause now.
Sorry, I was on mute. I do.
Yeah.
Yes, I do.
Very cool. Okay, we're saving the Soul Nebula, and then we're going to save it just like you see it here, because what you see here is gorgeous. Okay. All right, and then we'll clear it, get out of it, and go back to our initial setup. Okay. 1 second with our hyperview added. Boom. There it is. Okay. Now let's get out of that view. I want to see my telescope right there. Here it is with our control system. All right.
We gonna try? Excuse me. We gonna try for Webb now?
I'm not sure. I don't know if we can, but
Yeah, it's still a little early yet.
yeah. Do you know where the Webb is actually located?
Just generally speaking, it's in Orion right now.
Yeah, but do you know where?
I have the coordinate provided by.
Yeah, it was
provided
3
by
hours and
Curtis.
something. Yeah. What I need to do, I haven't done, is within Stellarium here, I can add the horizons so I know where our limitations are. And that I have not done yet. That's next to do. Every square in here, guys, is something to look at. Now I've added a ton more in here. We'll be in. These little H2 regions are cool. Let's back out a bit. Let's go see. Alright, so where we are right now is looking almost straight up. You can see the scope right there. And Orion is actually pretty high. And it might be high enough to check out something. It's still a little bit early to. It's 30 degrees, and yeah. Okay. We'll get here.
It's currently at, I guess, right ascension first, correct? 6 hours, 19 minutes, 49 seconds. Declination is plus 00. 27 minutes, 15 seconds, I assume.
That's right on the equator.
Yeah.
Okay.
Which makes sense where they want to send it.
Yeah, and it's probably going to be heading at sort of a northwest or northeast type angular trajectory, I would think.
Couldn't say.
West, I don't think.
Couldn't say offhand. Right. I know, watching the Webb telescope's site at NASA and stuff.
Yeah.
I think we've shared the links to them. If you watch, the spacecraft's location, the telescope's location, its velocity, et cetera, it has slowed down a lot from when it launched. I mean, I don't think it's even moving quite a kilometer per second now, which is pretty slow.
It's like a car going uphill.
Yep.
It's a car going uphill, and then it slows down to a stop just to get to the top of the hill.
Yep.
That's what's going on, and the hill is caused by the sun, Earth, and Moon.
Yep.
Gravity.
So hopefully, I mean, the numbers that Curtis got for us were for 0300 hours universal time, which is 8 o'clock here, Mountain Time.
Yep.
And I think he specified Arizona as the location, but
yeah,
it shouldn't. I wouldn't think it would move that far, like over the course of the next hour or two.
Yeah, not with a 2-degree field. We should still have it in the field.
Right.
Okay. We're heading to look at something called the Flaming Star Nebula. That's the Flaming Star. Okay. Let's move over a little bit. Oops, wrong way. Oops. I went too far. Alright, there we go. So now let's just do that one quick pop. And then let's go and set our speed down to a slower speed. Excuse me, I sneezed. Don't worry,
Bless you.
I wasn't wearing a mask. Here we go. See, as I do this, look at the color of the stars. You see how the stars are different colors? That's what's incredible. When you drag out the lines of the stars, you actually see the color easier than if you just take a picture of the stars sitting still like this. Yes. Waltz of the Flowers by Tchaikovsky, I believe. Okay. Okay, now let's go and... This looks like a good setup. Shall we? Yes, we shall. 30 seconds. Take off the hyper shot, go into the live stack, and await our destiny. It is your destiny. That's a big dog. My purple hair, Marc's purple hair is making me happy. Well, you know, I could change it to any color you want. You know. Okay, here we go. And there is the beautiful... Let me just do this. There we go. There's the Flaming Star Nebula. Look at that. That's just gorgeous. So, okay, now Izabela asks, Marc, now that L2 is occupied by the Webb, would it be possible to park other objects there, like future large telescopes or repairing robots or anything? The answer to that question is yes, because the L2 is not a small place. Okay, I forget the actual size, but we're talking about many, many thousands of miles in size that this telescope has to operate in, or more. I mean, the size of the ellipse is huge that the Webb actually will be orbiting in.
Yeah,
it's all part of the L2.
As you just said, the Webb is not going to be sitting at the center of the L2 point. It's going to be kind of orbiting it.
Yeah.
Over the course of I forget what is it, 21 days, something like that.
Yeah, like a lunar, almost like a lunar cycle.
Yeah.
And there's no coincidence.
Yep. If you watch one of those Scott Manley videos where he talks about the Lagrange points, he shows them as locations of gravitational equipoise on sort of like the opposite of those demonstrations where you stretch a piece of spandex and drop weights on it, you know, to look like planets and stars and such.
Yes.
Gravitational wells, I guess, where they're like hills instead of valleys. And some of the Lagrange points are bigger hills than others, and you've got a lot of room up near the top of each one of the hills where you can hover pretty well with minor, you know, transactions of delta V or rocket fuel in effect. The L2 is actually one of the smaller ones. That could be
L4
why
and L5 are
yes.
bigger.
Yeah, the Trojan points, like with the Trojan asteroids around Jupiter in Jupiter's orbit, those are
and
huge.
We have asteroids at L4 and L5 here too.
Because that equipoise location is, I think, relatively small for L2, is probably one reason why they're going to be orbiting it instead of trying to stay in the middle. But there's, you know, space is big and there's a lot of room out there.
Yeah.
And I'm sure they could park all sorts of stuff out there.
So that range that the Webb Space Telescope has, they're also calling it the equipoise. It's basically the range that the telescope has where it can remain in this metastable configuration at L2.
Mhm.
So that's when he's saying equipoise, that's what he means. You know, astronomers, we love to throw all these big terms around, you know, just confuse you. Look at this. Wow, look at that. Boom. Wow. Look at this, just. It seems effortless, doesn't it? It seems effortless. One of these days, I should go through everything that had to happen for this simple thing to happen to show you. It's amazing. 'Cause I just did it. Okay, but in looking at all the steps that it took to get here, wow, it's amazing. I can't believe I had the energy to do it, and here I am thinking I want to do it again and again. I've got ideas, you know. I've got ideas, Marty. The telescope behind me might end up going out there, and then a different one might go out here. We're also looking at solar telescopes, by the way, to actually be able to do things during the day as well. I'll never sleep. I'll never get any sleep, day or night. Or I'll have to run in shifts, or I'll have to have people doing different shifts during the day or night. That's the idea, by the way. I'm working to the point where we'll have operators who are going to do this as well for you. But they have to be extremely responsive to you. They would have to answer your questions. They'd have to be just as knowledgeable. So I think we're gonna have to go that route eventually, because there's gonna be just too much with not enough time in the day. I mean, I could do a solar stream for a large flare, and then that night, how would I bring this to you? Only if someone else did it. Gee, I wonder who could do that. Gee, Daryl, do you know anyone who might be able to do that?
I'm sorry, Mark. I was a million miles away. You're probably talking about me.
Yeah, I was just suggesting that maybe with a little bit of training on the back end here, you could probably do what I do here. And take it if I have to do a daytime stream or something. I'm sure you would enjoy doing this. Imagine being at the reins of a telescope like this, huh? Gosh.
Maybe. I'd hate to crash the system.
You might crash the system once or twice before you get through it, but, you know.
Yeah, well. When the Greeks count time by Caleb's.
Or we go back to cubits in Egyptian times. Leslie, that's nice. Thank you, Leslie. So, yeah, and Izabela knows Daryl can do it. Yep. Well, it's not a matter of delegation, Bonnie, at all. You know, I'm not like some big boss, okay, that delegates like a manager would. You know, I get your point, though. I mean, it's just a matter of being able to have enough hours in the day to actually get what we call sleep. You know? I mean, think about it. I was streaming James Webb for hours on Christmas morning. You know, that's pretty crazy. Daryl was there too.
Hey, I got up earlier than you did.
Yeah, you certainly did, because you were 2 hours behind me.
I got up at 4 o'clock in the morning to do that.
Oh yeah.
And you talked about Christmas presents. I didn't get to open Christmas presents until that night.
Wow. Well, I didn't get the Christmas present I needed until yesterday. the computer that runs all this needed a new graphics card. As you can imagine, this stuff is pretty graphics intensive. So I had to get a new graphics card and get it installed in the system. And I did. It's installed. And it's transparent to you. You don't see the difference. And that's fine. But it's definitely a brand new system.
Cool.
Yeah. And it's a lot faster. No crashes at my end. I mean, sometimes it would crash here. Okay? That's the telescope system we're talking about, the one here in Connecticut. I had to get that one high end. And so I did that. And Yvonne's right. That's why you delegate. That's right. But I wouldn't. It's like we're a team, you know. Donald Kunzer says, Mark, I'd host the show. What with my mythical universe and the Menzel Field Guide of the study. Menzel's Guide was fantastic, wasn't it? Remember Menzel's Guide to the Stars and Planets? Field Guide to the Stars and Planets. Remember that?
No.
No? You never had that guide? Wow.
I have no idea what you're talking about.
Okay. Curtis, I ended up getting a 1060 6 gig card to manage the tasks here. I had a 4 gig card earlier, and it was failing, and that was a problem. So that's the GPU in here. It's an NVIDIA chipset, of course. That's a 1060 card, GTX 1060, I think. I have the box right over here. But I installed it yesterday and put it through testing, made sure that it could handle the toughest of tasks, and it could. In flying colors, I was like this, like I was waiting for the computer to go poof, because it did every other time. Because see, what we also do is we'll use other programs in concert with this, and we'll show things in the background. And a couple times when I was doing that in testing, the computer started blowing up, and I couldn't figure it out for the life of me. So it was kind of difficult to figure that out. So I discovered that it was actually the video RAM memory on the other graphics card in the computer. So I ended up having to get rid of it, you know. Oh, Curtis says, I have one as well. I recently got a 3060 from EVGA. Waited most of 2020 to get it. Yeah, to get it at a good price. I literally got this card. And to folks that don't buy graphics cards, this is going to either sound like a lot of money or a heck of a deal. It cost me $485 for this card. I searched far and wide and I got it used. And then I looked at the metrics of the used quality, who used it, how much it had been used, and for $485 I could not go wrong. And I went from DVI to DVI outputs on the card to the or HDMI outputs on the card to the DVI inputs on my monitors, so I wouldn't have to change the monitors. I have several monitors here. That's why you see me looking this way sometimes, this way, that way, that way. So, yeah, Amal knows it was a good price. And this, especially right now, you want to get a new card, you're looking at $1,200, $1,000, $900, $899 for a deal. Who would pay that kind of money for a graphics card? You know, people that need them, I guess. And by the way, we're not doing nothing. We're waiting. We just stacked 25 images of the Flaming Star Nebula here. Now, I want to point out something while we're here, by the way. If we zoom into this nebula, you can see some features that are very fascinating. Okay, first of all, hot stars have lots of ultraviolet radiation that pours out. That radiation, along with other hot stars in the neighborhood, will cause the hydrogen gas to glow, and that's the red glow that you see, permeates the area. However, we also have this bluish cloud right here. What that is that's called a reflection nebula. It's not created the same way at all. It's actually dust mixed in with this gas of the hydrogen, this hydrogen gas, and the dust is actually absorbing the blue light from these hot stars and then scattering it back out to the universe in all directions. So everywhere you look at this nebula from, this will look blue to you. And this is blue for the same reason, as I've said many, many times, that our sky is blue. It's the same process. It's called scattering. In this case, on the Earth, the molecules in the atmosphere will take in the frequencies of light coming from the sun, which includes blue light, red, orange, yellow, green, blue, indigo, and violet. And the blue light comes in and gets kicked out in all directions. So the rest of the light kind of comes through unimpeded, effectively. And so that scattering process leads to our sky always looking blue no matter where you look at it from. Okay? Because the blue light is scattered. Well, in the same way, we see that atoms of dust and little molecules of dust out here, and the different types of compounds that are in these dark clouds of dust, also scatter light from the stars. And it seems to be a universal thing that the higher frequencies, the more blue, like my hair, okay, gets scattered. And that's what we're seeing here. Is we're seeing the scattering, and that's why this looks blue. So there. Now you know how reflection nebulas work, and how emission nebulas, which are the red ones, work. That's hydrogen gas glowing. This is dark dust scattering when you see the blue. Very cool. All right. So I think I'll go back to my auto size here. I hope we don't have to wait to look back into Orion. I'd rather do that tonight if we can, but it's like 10:30 here. Maybe another hour. I know there's plenty to look at. Alright, so let's go in here now. 32 of these stacked. So we're going to save this after we pause this. We're going to save the 32. See the fits file goes across the top there. That file will go up and get loaded up. That's the stack. That's the stack sandwich of images. It's raw. And you can process that yourself if you know how to. If you want to, you're welcome to. I'm also going to save this just like you see it, so that if all you want is the pretty picture, then you can go get the PNG file, the PNG file, which every system knows how to open these files now. And the PNG file is now there for you as well. So enjoy. And we'll clear and come out of here for now. And Vera Lucia, how are you? Yes, better late than never. It's nice to see you. Thank you for coming. Vera's from Brazil. Alright, let's go do this now. Did you see any objects that you wanted to look at yourself?
No, I've had my hands kind of full here, trying to figure things out. Carry on. You might want to try to find Webb at the top of the hour at 11 o'clock your time, 9 o'clock mine.
Okay.
Curtis ran the numbers again and got them for 4 hours universal time, which is 9 o'clock my time.
Okay.
Or 11 o'clock your time.
Alright. Alright. Let's back out of here for a minute and let's start playing down in the region of Orion. See how far we can go, what we can get to.
Heck, there's the crab right there. Do the crab.
You want to do the crab? I guess we could do the crab. Alright, we'll go to the crab next. Crab Nebula is a supernova remnant. And let's get back out of this ring. There goes our wonderful stellar view. You see how the telescope's pointing kind of toward this part of the roof? That's toward the east, and that's where that light from Phoenix comes in. Now, you don't see that with your eye when you're out there. It looks like a beautiful dark sky, but the sensitive cameras can see it, so we avoid that. But there's the crab right up there, and this is the star that's using as a guide, and then it's going to pull this in. The crab is beautiful. When you zoom in, you're going to see this filamentary structure, unlike anything else that we've shown you. Beautiful. Beautiful, beautiful. Okay, so let's move it over. Move it over. That's fantasy. He says, all right, Crab Nebula. You got it, man. And when we zoom in on it, I think you're going to be pretty happy that we did. And I'm going to check focus as well, because the temperature drops out there, and as the temperature drops, the focus changes. And it looks actually pretty good, but I'm gonna go to 100% and see if I can see the pulsar in the middle. If I can see the pulsar, then I know we're pretty close to well focused. It's there. Focus has been pretty good all night, Daryl. I'm amazed, actually. Usually we have to change it much, but because the temperature drops so much out there, to get an idea what the temperature is out there, let's take a look. Okay, our focus works in tens of thousands of different steps. You can go one step out of tens of thousands, so it's very, very accurate, right? But the temperature right now, and I'll show you, right? Temperature right now is 42 Fahrenheit, okay? Or for those of you with Celsius world, that's 5.6 Celsius. And the camera is operating at minus 10 Celsius. So the camera is very cold. Okay. So far, so good. All right. So that said, let's bring this up into the center. All right. And we don't have to put it directly in the center, but we can do that if we want. You know, move it in there just for the heck of it.
I don't remember seeing the big red X before.
No, this is a reticle that's part of this. I could do that too. It looks neat, but it interferes with everything, right?
Yeah.
Okay. So there we go. All right. So now, let's go and we'll leave it actually at 100% of the frame right now. You can even see a real fine filament once in a while that shows up nicely. It depends on the moment-to-moment changes in the atmosphere. But let's go look. Let's do 30 seconds out here again. All right, and go into our stack. And we're gonna clear the last one. Alright, and then I gotta come back here, actually do this. Oh, let me get rid of this. Just a sec. Oh. I had 30 milliseconds. I'm at 30 seconds. That's not going to show anything. Alright. Here we go. David Lee is a troll. Somebody get rid of that, please. Alright. So here comes the first crab. Oh wait, I gotta clear it. It had other exposures tied into it, unfortunately. Alright, so let's do this. Okay. Here we go. Yeah, thank you, Bobby. Okay. Now watch how the noise gets reduced immediately. Ready? Watch right here. Watch this noise go. Look at that. See how it gets away? That's going to happen over and over and over as it gets farther in. Look how bright it is in the center. It's almost too bright. So what we're going to do is we're going to actually take it down a notch in the center to allow us to see what's going on in there. And you'll notice when I do that, this little dot appears right there. See that dot? That's the remnant left behind of the star that blew up. That's called a pulsar. It's the Crab pulsar. It's spinning 33 times per second. That's the remnant star that you can see with your eyes thousands of light years away. And that star is only the size of Manhattan Island. Let that sink in. Let that sink in. Thanks, Izabela. Why don't we bring that up? Come here. That's better. These colors that you see in the Crab Nebula are real. These are ionized elements from the debris of the star that exploded. We see lots of elements in here. We see some oxygen, we see some hydrogen. There's also neon and other elements in here that are glowing. There is the entire chemical maelstrom that was inside this star's envelope that's now here. It's just beautiful. And this is the one-to-one shot, by the way. If we actually went down to fit it to the screen with our field of view, look how small it is in our field overall. That's how small it is. Well, we can handle bringing it up to 100%. See, this telescope is set up to bring you the best of both worlds. And I think that's just what we've done. I'm going to increase what's called the black level so we can actually take the star or the background down to a darker color, which is what about we need to do. So I'm going to do that right now. It's a subtle change. It's almost imperceptible change. But a little bit goes a long way. That's probably too much. Oh, that works. Look at that. Wow. You know, as a kid, I tried looking at this nebula with my telescope. Hopeless. I mean, I saw a little fuzzy thing. And I had a smaller telescope. And then when I actually was able to see it with SkyTour LiveStream telescope for the first time, I literally couldn't believe it. I stared at it and just kept staring at it. Is it real? Is that real? Wow. And I realized the absolute catastrophic cataclysm that bore this. And I thought, if there were any civilizations in range of this supernova, they could be destroyed. If there was a star 20, 30 times the mass of our sun, about 6 to 8 light years away from us, it would go supernova when it died, and when it did that, it would take us out. It would. How? Well, this material arcing away from it will go thousands of light years away over time. It will cool as it does, but initially it's going to be extremely hot. It'll be just luminescent, okay, because it's so heated. And if it passes through our solar system, it's going to boil away the atmospheres of Saturn and Jupiter, Uranus, Neptune, Mars, what little's left, and of course the Earth. Venus would probably feel right at home, although most of it would get boiled away. Wouldn't affect the sun. The sun would keep on going, because that's a stellar type thing. The stars wouldn't matter. But this would be devastating to a civilization. So I remember thinking, what if there was a civilization near this, you know? It really was kind of sad to think about. Daryl, this looks pretty good considering it's leaned over, looking that far over on the eastern side.
Yeah.
So if you notice where the telescope is here, you can see it's not bad though. The Regal Crab Nebula, born from the most cataclysmic explosion, one of the most cataclysmic type explosions the universe has to offer.
There you go, one of.
Yeah.
What you were saying a minute ago, I was wondering, you know, they usually say Betelgeuse and Antares are like the two most likely supernova candidates in our part of the sky. And they think they're far enough away they wouldn't hurt us. What about a gamma ray burst?
Gamma ray bursts would be fatal
to
us.
It's such a
It's
distance.
different.
Yeah.
It's subject to distance as well.
I mean, I read somewhere.
Gamma ray bursters are like pulsars, essentially. They have lighthouse beacons of high energy that go streaming off of them. And if one of those gamma rays happen to rake the solar system and the Earth, it could be very dangerous. There could be a lot of cancers and devastations and health effects from that. And depending on how long it took, the night-facing or even day-facing people, whoever was subjected to it, if it happened on the night side, then the daytime folks probably wouldn't feel it. You know, nighttime folks would get hit with the full brunt of it.
Yeah. I seem to remember some video in the past. If a gamma ray burst hit Earth, they said it would sterilize everything on the facing side of the planet.
Yeah, no doubt about it. Okay, we've got 18 exposures here stacked, and then we're going to save it exactly as we see it. So if you want to look at one of the most cataclysmic types explosions in the universe, the Crab Nebula will be up there. I'll be labeling these with the actual names in the directories up there as well.
Have you given any thought to relocating the telescope inside the observatory, that farther away from the roof line? Of course, I guess that's what you're thinking of with that column.
Yeah, but I got 2 columns coming, actually. 2 lifting columns. They're going to lift the telescope up like 17 additional inches. But the reason that I didn't want the eastern side even tempting me is because the camera would see that very, very tiny light pollution from Phoenix toward the east. So that's why I don't care about that.
Well, that's pretty much what I figured.
Yeah, we rushed the season now. I mean, yeah, we're rushing the season now. The Crab Nebula is going to be way higher and overhead by the middle of the season. We're seeing it really nice right now, but look where the telescope's pointing.
Yeah.
It's going to be pointing overhead before long, and the view's going to be probably like 1.5 times as good as this one. Might even be better, obviously by a lot. So, and then we looked at the Orion Nebula already, the Horsehead Nebula, and the Rosette I took an image of. And that was something else, you know? So we're going to clear this and kill this. And let me go back into that because it wouldn't let me kill it before it went away. Away. Away with your... Away. Yes, okay, now let's go and do this. Let's do this.
Izabela says your voice is lower than the music.
Yeah, I addressed that earlier when I saw it.
Oh.
I just did it quietly.
Okay.
Yeah. I turned down the music a little bit. But your voice is okay, right?
I don't know. My voice okay, folks?
You're coming across about the same volume as I am.
All right.
Yeah.
Well, I noticed. I went back and reviewed the live stream we did for the Webb launch, and you were much lower volume than either myself or Amanda.
Okay. I have a mix button here on the mixer, and I've mixed my volume in loud so that now you and I are equal. I can actually put you down way lower than me.
Yeah.
But I would never do that to you.
Okay. Amal says I'm okay.
Okay, good. Okay, well, let's see. This is what the Crab Nebula... With this here, what you're going to see here, that's about the best I've ever seen it in my telescope. Not this telescope, but when I was growing up as a kid. It actually wasn't quite like that. Let me show you actually what it looked like. Just to give you an idea. Okay.
Thank you, Vera. I don't think I've ever been called having a beautiful voice before, but thank you anyway.
Well, that's very good. See that, Daryl? You got to hang around here much more often. Okay. This approximates what I saw with my telescope when I was a kid. That very faint little fuzzy patch. And to see it better, you look at this star over here. And then the black and white receivers in your eyes, which are much more able to see dim light, will pick this up easier. That's called averted vision. Yuffie says the master gain is low compared to other content on YouTube. Well, I don't know. I don't measure my content gain. I don't measure my gain relative to anybody else. You know, because people are free to they mix whatever they want. That could be true, but I'm not. I'm bordering on the red for Daryl and I in our broadcast software. So I don't know. Maybe everybody else is too high. I'm sure there's not everybody else is wrong. Okay, all right, let's go in here now and let's do this. Okay, now let's, well, first of all, let's go put this in to automatic.
Thank you for indulging me.
What's that?
With the crab.
Oh, the crab? Is that the crab?
Yes.
Oh.
Remember, you asked earlier if there's anything I wanted to see, and at first I said nothing I could think of, and then I saw the crab right in front of me, and I said, hey, let's look at the crab.
There you go. Hey, Kathy Pernisek, how are you? Happy New Year to you, too. Okay, let's go back now. Let's see. Let's see what we can do, shall we? What was the declination of the Webb?
Oh, I'm glad I'm not on camera. I have to put my glasses on to read my own chicken scratches. The declination 002740.5. 0 degrees declination, 27 minutes, 40.5 seconds.
Okay, and it's 6 hours.
6 hours, 19 minutes, 41.8 seconds.
Okay, so it's basically almost near. It's kind of between the Orion Nebula and the Rosette, if you draw a line between them. Because that is that spot you're talking about. This is 0 right here, and that's 0, right? Yeah. Let me get rid of this for now. Okay. Okay, this is 0 right here, and it's 6 hours, 19 minutes. So it's really, we're talking about, it's in this region right about here. It's kind of relatively near this, if I get it right. That's 0. And that's even lower, but I don't think I have a star that I can use. Maybe so. That's kind of close. 0, 19. Yeah, okay, that'll work. And then as far as 6 hours, let me get rid of this for a minute. Can I do what? Sorry.
Can you do a go-to by coordinates? Can you enter the coordinates?
Yes, I can, but I was just trying to see what would happen, because it's going to be approximately here. Okay, let's just say it's going to be just about here. All right, if I was to bring up the grid here, okay, this is the actual field of view that we'd see. And as you can see, it covers quite a bit of space, so the Webb will be in here somewhere.
Yeah.
But how high is it? And at that point, 35, boy, that's close. Let's go to Betelgeuse. All right. Let's see if we can go to Betelgeuse. Okay. Now you might wonder, you might say, well, why not just say go to this location? I'd like to, but look what's going on in the building over there. Okay.
Yes.
You can see that the telescope is pointing a little bit at the roof. And there's Betelgeuse. So we have to wait for it to come up a little higher.
Yeah.
But we might be able to... I could try something. I don't know if it'll work. These halos are an artifact of the system, but I'm working out a way to get rid of these halos, and some of you have seen the results. They look pretty good.
Oh, yeah.
So getting rid of this halo around Betelgeuse, no problem, and it wouldn't destroy the stars behind it. Okay. Now the thing is, Orion's on its side, so if I went south a little bit, I might be able to get to where this is. So, so the coordinates then, the right ascension is 6 hours, 19 minutes?
6 hours, 19 minutes, 41.8 seconds.
Okay, 41.8.
Declination is plus 0 degrees.
Okay,
20,
0.
27 minutes, 40.5 seconds.
27 minutes. 40.5.
Yes.
Okay. Well, let's say go to and see what happens. It may not work, may work. If it doesn't work, we'll have to mess with it. Either way, it's on its way.
Oh, I see. I'd wondered. I hadn't seen you use the go-to boxes in your
it's picking Betelgeuse. Well, that's good, because now it'll just move the telescope to the location, and it won't be confused by the fact that it can't see Betelgeuse, because it certainly can. All right, that's good. And after it does this, it's gonna zip on down. Yeah, you can see that red that you're seeing here.
Which is
well,
the
we got
roof.
the field anyway. Actually, I say this at the end of the telescope is the camera, and the camera has a tiny, tiny little red LED on it. The camera's so sensitive, you're seeing the red LED reflecting on this wood, which is about 2 feet away from it. Okay, that's crazy, isn't it? You know what, though? While we're here, what the heck? We can try it. We can try a exposure. Let's do 20 seconds. It's going to be really bright. Let's see if we can see the trail. I've got it at a reasonable gain. We'll try it. All right. And I'll take this off for now. And we'll stack it anyway, just to see what we get. I don't expect that it's going to work too well until we actually get the this thing to look good. You know, clear of the building, in other words.
Yeah.
Well, we have that, though. I mean, we still see the stars.
Well, I see your telescope. I mean, it looks like it's pointing right at the roof.
We're only getting about half of the clear aperture. And 20 seconds is probably not nearly long enough. Based on the way it's moving, we probably need to do way longer exposures. But the idea is to look for a star that's slightly oblong among the stars that are round. You know?
Yeah.
And we're stacking right now, so it's going to just create a worse and worse and worse one. And it's going to be pretty... I mean, the part of the sail, part of the parasol, has been deployed. You know?
I read that they delayed the tensioning of the sun shield for a day. I guess they were running late when they deployed the booms on the sun shield yesterday, so they thought they'd take the day off and do it tomorrow on the 2nd.
Right. But they didn't... Go ahead.
No, go ahead.
I was going to say, the way that deployed, and for those that saw our SkyTour live stream that we did on the James Webb, that sun shield, it's a diamond shape. And right now, that diamond is in place. But tensioning, what that does is it takes the stack of 5 layers and separates them one by one.
Yeah.
And that's what we're waiting for. So we do have the full diamond shape at our disposal to see. So as we stack here, we want to look for a star that's more oblong than the others. And that'll make a trail. Now I could do like a larger... Hey Papa Tom, thanks for coming.
See ya, Tom.
Glad you enjoyed us for a little while. I don't know, I don't have a finder for it, so I don't know where in the field to look. It's going to be one star that's dragged out in a line, like when we see a satellite, but it'll be smaller. Because it's not orbiting the Earth, it's actually moving freely through space. Let's go to 50% here. Get a little better view. Hey, D. Smith. Wow. I'm sorry. D. Smith had a twister nearby. So that's scary. Okay, I see that we're having a little bit of a tracking error here. So that's no good when you're trying to figure out what star is oblong. So I will just clear that stack and start over. It's hard to guide when it's got doesn't have a full view of the sky. The guider is actually, the guider operates independent from this view, and the way the telescope is sitting right now, the guider may not see any stars. So we're looking at the telescope. The telescope is, see, that's what's happening. The guider can't see the stars.
Yeah.
D. Smith, right? Mark, all is well. It's Podunk, Alabama. Wow. And Kyle Lynch is here. Lynch Hub, what's going on? Yeah, the color is off, Curtis, because I mentioned there's a red light on the end of the telescope that's in the ASI 294 MC Pro camera, and that tiny little red LED is more than enough to reflect on the building that you see right here, the wall, the roof line, and cause this red glow we're seeing. I mean, I guess I could try and color correct. Okay, so that's sort of color corrected, but you know, we're also not getting the benefit of the auto-guiding system because the auto-guider is a separate telescope mounted on this one. So we're not getting the benefit of it because it's on the other side of this one and it's fully blocked. So right now, if we could see its guiding status, it's going to be blinking, you know.
So, come back later or wait a while or?
Yeah, we have to wait a while.
Yeah.
But there might be some other things we can check out.
Could I pose a question while we're...
You may.
Okay, talking about the sun shield on the Webb, I had been considering this lately. What kind of degrees of freedom, I don't know how else to put this, will the telescope actually have? If the sun shield is always going to be facing the Earth and the sun, it's in effect, it's going to be dividing the sky in two from the Webb's point of view.
That's right.
And well, at best, you have half the sky visible to the Webb. But is the mirror fixed in position? I was wondering if the mirror can't pivot up or down, you know, or rotate in what the equivalent of azimuth would be from the telescope's point of view.
Well, it can rotate in azimuth. It can rotate in azimuth all day long.
But the sun shield goes with it.
That's correct.
Yeah.
But as far as up and down, I actually haven't seen the mechanics of it to know what that actually does.
Yeah. Well, maybe you see what I'm wondering then. I mean, is the mirror fixed to the is the mirror fixed to the rest of the sun shield, that center hub and everything? In effect, can it only see like a torus shape? What you would describe if the whole sun shield telescope and all was rotated around its center, and yet maintain the shielding from the Earth and the sun.
Yeah.
You see what I'm saying?
I do. I mean, it's be interesting to find out just what the telescope can actually see. I agree. I agree with that.
And if that was the case, then it seems like the telescope may have a rather narrow observing window that, like, you'd have to wait week by week or month by month, for a new section of sky to open up.
That's true.
See what I'm saying?
I do.
Okay.
I do. I see exactly what you're saying. I'm going to do something else now. I'm going to stop this stack for now because we can't guide on this, so that's not working for us. Our guider doesn't work. We're going to have to guide on it. So out we go. And then here. And now do this.
Blues Traveler in chat. He's responding to my question, I guess.
Okay.
Says JWST does not have an unlimited field of view. At any given time, telescope can see 40% of the sky from one position. And then can see all the sky over a period of 6 months.
Keep in mind that at L2, as it orbits the sun, it's looking at different sky all the time. So there's different objects presented to it over time.
Right. Which is kind of my point. You'd have to wait while new sky sort of rolls into view as the telescope and the Earth orbit the sun over the course of a year.
And that's true. That is true. All right, we're gonna go. I'm gonna go to Alnitak right now. Actually, we'll go the Flame Nebula. That's good enough. All right, let's see what the telescope does. Going back to. It's gonna take us to Betelgeuse again. Nope. Taking us to Bellatrix, which is the right-hand star in Orion. There's Bellatrix.
His left shoulder.
Yeah. And then we're going to go down to the Flame Nebula. We'll check that out. The Flame Nebula is just beautiful. Yeah. The Flame also has the Horsehead in it. And I think we have clear aperture here. So I'm going to bring us down a little bit. Now we're heading south, which means that the telescope is sort of coming toward us in this view. So we're not running out of clear space. That is to say, we're not running into the roof line too much. There is the Horsehead Nebula right there. And this is just a 1 second exposure. So that's pretty good. And there's Daryl's favorite star, Sigma.
Yep. One of them. You can see it's a multiple star.
That's right. It's responsible for causing this hydrogen gas here to glow. Yeah, go ahead.
Yeah, that reminds me. What was it? Thursday night. Couldn't see anything last night. Thursday night, I was out after sunset with binoculars, and I could actually see the crescent phase of Venus in binoculars.
Oh wow!
It is a very, very skinny halo, very skinny crescent now, and it's over a arc minute in diameter, and was enough to show it in binoculars.
That's outstanding.
Mercury was to Venus's upper left by Thursday after sunset, but the sky was too bright for me to pick it out.
Okay.
Venus is going away really fast. Mercury is going to keep rising. I'm sorry.
It's turned the corner.
Venus?
Yeah.
Oh yeah, it turned the corner a couple months ago. And it's about to pass between Earth and the Sun on January the 8th. Mm-hmm. Mercury is going to continue rising, and if you can see Saturn to Venus's upper left now, Mercury is going to be moving up toward it. It's not going to quite come close enough for a conjunction. It's going to Mercury is going to round the corner in its orbit about January the 11th, I think. It's going to sort of hover for about 4 days from the 11th to the 15th, just to Saturn's lower right. But anyway, carry on. Pretty picture.
Yeah, this is the Horsehead Nebula here and the Flame Nebula here. This is Alnitak. Alnitak is the leftmost star in Orion's belt. And see, here we have a clear view. We have to just wait a little longer. But look at this. This is beautiful. We're stacking this one now, as you can imagine. And our guider is working properly here because we have a clear view of the sky. If we go to 100% on our sensor size here, you can see the noise in the dark nebula here. And that's going to go away. All right. If you just keep staring at this, let's see what happens now. A little bit. See, a little bit more went away. And over time, more will. Notice this light area on top here. Notice this light area here and a little bit of a light area here. These are areas that are less dense, and so we're seeing stuff through them, and they're actually doing some of that scattering process we talked about to show you that light in that blue wavelength. Same thing here. This is inside the nebula, and you can actually see that this whole area is a giant dark nebula in Orion, a giant dark nebula here, and this is sort of like a wall. So this is an edge of a giant dark nebula. There's more here, so bring it over a little more. Let's actually maximize this. Ready? Boom. There we go. Now you can see this.
Mark, excuse me a moment, please.
Sure. And this is live. This is a live view. This is just crazy. There. Wow, that's just something. I know, Vera, it looks unreal, doesn't it? But I promise it's real. It's just something, I'll tell you. Let's zoom in on this. Let's do it this way. Look at that. Wow. This star has 4 or more components to it. And that is why the star can bathe this hydrogen gas that's mixed into this dark cloud with ultraviolet radiation and cause it to glow like it does. Hey Nick Tesla, how you doing? Really? A meteor, huh? That sounds awesome. That's right, JSCO. It's very regal, this song. It's a very regal song, you know? So Nick said he woke up to a meteor. So meteors can send big shockwaves. Where do you live, Nick? That's the Flame Nebula right here. Now, what's going on is this nebula, this black part right here, right? I'm gonna illustrate this. This black part right here is in front of, so it's in front of the brighter nebula behind it, okay? So it's actually blocking or occluding that that brighter nebula behind it, okay? But then these areas over here are actually inside the dark nebula. They're more inside this dark nebula. So their color is muted. You don't see it as this red like you see the stuff that's closer to the quote-unquote surface. It's more muted because it's mixed with some of that scattered blue light, and that blue with that reddish kind of ends up making this additional color. It's a lighter version of that red. So it's because this object is in a different density throughout its size, right? This stuff out here, right here, this is closer to the edge of the cloud, toward us. Okay, this stuff is farther into the cloud, farther in away from us. So this is all in 3D, remember. This is all in 3D, so it's hard to see that and hard to actually imagine that. But there you go. And Daryl's also said, that he looks at this, it's more of a gold color. Well, it kind of looks less gold tonight and looks more proper color. I'll do another color balance to see if it changes. And it doesn't really change much. Then I'll do a push a little bit, and you can see a little bit more detail out here. Now what I'll do is get rid of this and back out a bit so you can see the rest. Now that it's been pushed a little, and you'll see some new details. Okay. So over in here,
Flame
you
looks
can
a
see
little
new
more
details.
colorful.
Yeah, see, I mentioned that while you were away. I said the flame actually looks more red tonight than other nights.
Is that just where you
However,
have your color balance at?
no, actually, it's actually because whatever the flame was balanced for, this would be balanced for too, right? The Horsehead versus this. So these look more the same, but you still have differences. We have that scattered light out here, like blues that are mixed with these reds, because this is, as I mentioned, deeper into the nebula.
Yeah.
And still glowing in there, but it's coming through scattered light too, so the red and the blue are kind of mixing a little bit. So it causes the hue to change. It's interesting, this whole region is so full of dust and gas, like right here. Okay, look at there's more here.
Oh, yeah.
And it doesn't end. This is a giant element of part of a massive molecular cloud called the OMCC, the Orion Molecular Cloud Complex. And the Orion Molecular Cloud Complex is extremely rich in stellar building materials. It's the Home Depot, okay, of elemental production, in terms of storehouse. There's a lot of stuff in there. Now these clouds out here in the darkest areas, these are going to be really cold. And that cold is extremely important to star building and planet building. You might not believe it, but it's true. As they condense and they self-gravitate to each other, what happens is these cold dust particles are so cold that other molecules can attach to them and basically freeze. So you can get methane ices, carbon monoxide ices, CO2, oxygen compounds, hydrocarbon compounds, maybe, that are forming ices on the surface of these dust grains. And then that stuff is thank you, Curtis, for the update. So that stuff is really cold, and it could be close to absolute zero. But when the stars heat them up, those ices melt, and now you have a gaseous material around these dust grains, and a lot of it is hydrogen. So you end up with some really rich interstellar environments. Okay, let me just do one thing there. All right. Where is it? All right, there it is. Okay. 2022 January 2. 5. Wait, see. 5, 6, 19, and. Wait, what? I'm sorry, I'm just trying to get. Oh, there. I'm sorry, there it is. 61929 and 028 oh 5.4. Yeah, it won't make much of a difference from what we're looking at.
You know, the numbers are changing.
Yeah, they are.
But I mean, like from the 9 o'clock numbers to what he just gave us are the 10 o'clock numbers, my time, midnight your time. That's only changed.
Well, a minute of
15 arc seconds,
yeah.
46.8 to 29.47.
Yeah.
Talk about 15 or 16 arc seconds in right ascension. And 2740 to 2805. Still, I mean, that's 20 or 25 arc seconds, I think. About 25 arc seconds.
Yeah.
So it's not moving very fast.
So what it means is that we would have to expose for a long time and do a very, very long stack to catch this thing moving. Which is what I thought it would be.
You may need more
right.
focal length too. Or, you know, shoot the shot and then zoom in on it.
Yeah, because as you know, like, for instance, if we know where it is, we can go to 100% of the frame, which is right here. Watch the size of the Horsehead here.
Yeah.
Okay. Yeah, so. And look at the complexity actually of that wall.
Oh yeah.
That's just beautiful. Wow. Let's see how the Horsehead itself looks now. Oh yeah, look at that. That little scattered nebula over here is much more pronounced. Wow. And you can see lots of detail in this dark area over here too.
Yeah.
The devil is in the details, guys. Look at all this detail in here.
You can see wisp under the horse's chin.
Yes, you can, right there.
Excuse me.
Yeah, right there.
And the bigger one on the back of the horse's neck, where his mane would be. You're pointing right at it right now.
Yeah, right there.
Yeah.
Yeah, you can see the split right there.
Yep.
Yep.
And it looks like the very top of his head, like from his ears back a little bit. It's actually a little lighter there, like
a glow.
It's sort of grayish, but it's brighter. I'd almost wonder if that's almost like a little bit of reflection going on, like the blue you see up two stars to the upper left.
Yeah,
Rayleigh scattering.
Yeah.
Beautiful picture.
Look at these two. You can see the dark nebula here that's immersed in. Look at this beautiful knot. Look at that.
Uh-huh.
Wow. Ay, ay, ay. That's just something. Hey, DK, I don't think I said hi to you today. DK0018. Lizard Man from D&D games. That's funny. Look at this stuff out here. Holy cow, look at these areas. Oh, you can't see them. Look at these loops right here. And this little pillar. That's just beautiful. Wow. That's just beautiful right there. That's just beautiful. Wow. Okay, let's try a little processing here. I'm going to drop the black level in just a bit. And you got to be really careful with this because it could really quickly lose a lot of detail.
DK, I don't know the answer to that. Everything we see is moving, though, so that will change over time. I would say over the course of thousands of years, it may turn into something else instead of a horse's head. What would you say, Mark?
Well, because it is all moving, it's all subject to gravitational pull from stars all around. Plus, it has its own intrinsic motion as well. Okay. So basically, go ahead.
No, go ahead.
So basically, because these are all masses that are moving, they are certainly going to be. They're certainly going to be in motion due to the stellar gravity around. Plus, these clouds move as well on their own, so there's a lot going on. This is a horse's head for the moment, but at some point in the future, just like you said, this will warp and change. Things will happen.
Yeah.
So
we've mentioned before that when we look at the Crab Nebula, for instance, we can look back over about 70 years of imaging and see the changes in the crab as it has, expanded into space. The Crab Nebula is a lot. I forget the numbers. The crab's like over 6,000 light years away, isn't it?
Yeah, it is.
And here Orion, in general, is you're looking at 15 or 16, 1,500 or 1,600 light years away. So, it may be comparing apples and oranges, but I'm sure if you took a picture of this now and you go back and take a picture in 100 years, it's going to look, noticeably different. 100 years, 1,000 years, who knows?
I think you're right. So if you guys notice here, you'll notice that there are some really interesting little intricacies here. Let's go over this way a little bit. Okay, now we're all the way over in this field, but look at here. There is a dark nebula, there's a lighter nebula here. Look at this wisp here on the back side of the Horsehead Nebula. There's a dark piece here and there's a lighter piece here. Look at this. You can actually see that the Horsehead Nebula continues. The object that makes it goes all the way in through here. Look at that. This is only at 50%. Okay, if we go again, we go back out to the full view. This is what the auto size looks like of this area. This nebula is now much brighter and much more defined. This is much more defined. And you can see this whole area is bathed in ultraviolet radiation from Sigma Orionis, this star right here. And this whole area here, you can see is extremely well defined. Let's check out. Let's actually go to 150% right now, and because it turns out that this camera can support that. Pretty interesting. So let's go here. Let's do this. Here it comes. All right. So now, if we head to the left here, look at this amazing detail in here, Daryl. There's a star inside there.
Yep. DK, all of Orion Marc mentioned the Orion Molecular Cloud Complex earlier. It is a huge stellar nursery. It has been up there for millions of years. It has been changing for all that time. New stars are forming. Old stars are going supernova. As Marc has said in the past, when Lucy, the Australopithecus, looked up at Orion a few million years ago, which star did you say wasn't there millions of years ago? Was it Betelgeuse or something else?
Well, Betelgeuse was an O star back then, so it was a bright, hot blue.
Yeah.
But Alnitak may not have been there.
Okay. Maybe
Alnitak is only just over 4 million years, and Lucy, Australopithecus afarensis, like you were saying, Lucy would have looked and seen one, maybe two stars at the most in Orion's belt, and Betelgeuse would have been a blue hot star.
Yeah.
To her.
But I guess my point, DK, is what made it? An explosion, many explosions, turbulence in the cloud from the explosions. I'm. If you could see a really deep exposure of the entire constellation, you see where all sorts of things have been happening for a very long time. You see what's called Barnard's Loop, which is from an old supernova that happened somewhere down close to the Orion Nebula, I think, somewhere in that area. And it has been sitting there for millions of years, cooking away, doing its thing, forming new stars, blowing up old stars. The clouds are in motion. Everything is moving all the time, and it's getting stirred up from all these explosions and such. Many explosions over the course of millions of years.
Yeah.
I hope that answered your question.
This is really stunning. I mean, look at this beautiful nebula here. This beautiful nebula. Look at this now. For the first time ever, we can see that this dark nebula continues on down. It's a large strand. Look at that. And it happens to go over this particular reflection nebula. Do you see that?
Mm-hmm.
Yeah. And all because I'm playing with a little bit of the levels here.
You can see textures and whorls in the other star to the left also, which looks like a double star at least.
This guy here?
Yeah.
Yeah, look at this.
That may just be a line of sight thing, but boy, the one on the right there at the top, I mean, there's stuff going on in there.
Look at this. This area right here is like a breakaway globule in the making. And there's a thin strand connecting it to this guy. Again, might be line of sight, but isn't that something?
Yes.
Wow, that's just something. All right,
the little dark crook with the star at the bottom end of it, the other end of that crook, I mean, it's shining from light in the, I guess, star more toward the middle there too.
Oh, you mean this guy?
The other, if you follow that crook to the upper right, that right there.
Yeah, to here.
Yeah.
Yeah. I want to try and look at the enhancements here for a second. See what else I've got I can try.
DK, if you flew through it, would it be like driving through fog? We've talked before about a lot of times when we see a nebula up in the sky in space, that one reason we see it at all is that we're seeing it from a distance, and it's kind of collecting all that light into a smaller surface area. That if we flew through it, we might not really see it at all. I know there are videos on YouTube and elsewhere where they have rebuilt, say, the Orion Nebula digitally and then flown around it and flown through it. And the whole Orion Molecular Cloud Complex, I mean, it looks dense enough that yes, there are places where you would actually see it. I think you'd
Yeah.
have to say. Uh oh.
Okay.
Is that?
That's they don't see this. I'm actually looking at the weather right now, guys. Actually, I can show you what I'm looking at. So here is what we're looking at right now. Okay, this is high altitude clouds. That heart is our observatory. And so far we're in the money. We're in the money. But that may encroach on us before we can do what we gotta do. But we'll see. As you can see, this is really beautiful. This nebula here. I mean, look at this, Daryl. I am astonished at the colors and the variety of colors in here.
Yeah.
Wow.
No, that's really something.
Hey, weird guy. Yeah, thank you. I'm astonished myself. I just can't believe this. Such a beautiful take on these things. And you know something? It can only get better from here. You can do some things to make it look even better. I haven't seen before. We never actually saw any of these little protrusions of dark nebula off here. We've never seen those. We also haven't seen, as you pointed out earlier, Daryl, we haven't seen the chin diaper that the Horsehead is wearing.
Oh, I think it's been there. Maybe we just didn't notice. The amount of detail here is overwhelming, and maybe we got distracted by something else we were looking at. What really blows my mind right now is of the two blue ones up there, the one on the right.
Yeah.
That is just so deep, three-dimensional looking. I mean, it's like
it is
looking down into
like a hole. Well, keep in mind, right? Hot young stars, they create a cavity around them, and a lot of the dust and a lot of the nebula is, and a lot of the gas is being blown away by the immense stellar winds of these stars. So they tend to form like a cavity around them, and where there's dense areas, like in here, okay, like I guess, let me zoom right into this. Okay, where there's dense areas like right here, I guess there we go. This area here, this star might be, which looks like it might be a double itself. This star might be actually working on hitting that with very, very hot energy. There's some hydrogen gas ionized in here, but for the most part, this is a lot of dark dust in here. But it looks like this is sort of pink. Maybe there's some hydrogen that was ionized by this star. But notice that it's evaporating and there's a stalk here. It's like there's a dense area in here that might be forming. For all we know, we don't know. But it's just beautiful.
Yeah.
I am just... I'm amazed. This has never been this beautiful. I've never seen it this pretty. Here's the other thing. See all the stars that look red? Those aren't likely red dwarf stars. Those are likely stars like this one, or this one, or this one, but further away and inside the cloud. So their light is being reddened by the dust in that cloud in the same way that our sun looks red at sunset. Okay, particles, more blue light is scattered by the atmosphere or by the dust in these nebulae, and these particles scattering the light from these stars makes them look redder, just like our sun looks redder on the horizon. Thank you, Dean. Dean Bostador says hello to everybody, and how he likes this image. I'll show you, Dean. If you just arrived, I'll show you the whole image. Okay, here's the whole image, Dean, that you'll see in a sec. Look at that area. Now we've stacked 62 images. That's how much stuff is here, Daryl. We've been talking about it and doing 30 seconds, 62 images stacked. Wow. Wow. I think we gotta stop. Just stacking this. Okay, so I'm gonna save this stack. Right now Izabela's going, yay, because she wants to work on this. And then we're gonna save it just like you see it here. Right? And you'll see there it is, it's saved. This image you see right in front of you is going to be up on the server in just a few minutes. Look at all this nebulous. It's almost Daryl, like I don't want to stop.
Yeah.
I don't want to stop looking at this image.
Yeah. Well, that's something.
There's so much going on. It's so much deeper and richer than we've ever seen before. You know? So much deeper and richer.
DK asked, wonder if there are any planets in that area. I replied to him, there may be planets. Question is, could there be life on them? And I would take offhand all the really hot blue stars might be sterilizing any planets.
Yeah, but keep in mind also that some of the planets are going to be buried in denser dark nebula. But let me give you an idea. Oh, don't worry, D. I'm not going to stop until we do get clouded out, I promise. But keep in mind that the dense, when we say they're dense nebulae, let me give you an idea of what we're talking about. Okay, this is a cubic centimeter. Okay, it's a tiny area in a cube. Okay, cubic centimeter. All right. In every cubic centimeter of air, we have billions of molecules. Okay. In a cubic centimeter of space, we have about 300 cubic molecules. 300 molecules. So that is what the density is out in regions like this. You follow? It's a difference is night and day. I mean, it's so different. It's incredibly preposterous to try and suggest that it's anything like an atmosphere, right? The Martian atmosphere is millions of times denser than nebulae. Okay, so we're talking about an area of space. When you talk about flying through it in your spaceship, when you got close to it, you might not even know you're in it. Here's another reason, like another thing too. Let's say that what if the solar system and the stars nearby are part of a dark nebula? We're in it. We might not see it. We might not see it. And that dark nebula would be in our galaxy. Maybe we're in a dark nebula. We don't know it. You know? So that possibility exists as well. Boy, I just can't stop looking at this. This is so pretty.
I wonder if you look at the bright reddish streak running from near Alnitak down behind the Horsehead and on down past the Horsehead, silhouetting the Horsehead. Well, the Horsehead is Barnard 33. It's a Barnard dark object. But the brightest part of that line, is that like a wave front or a shock front, literally, from Sigma Orionis there on the right? Because that Sigma is supposedly what's illuminating or backlighting the Horsehead there.
Yeah, as we zoom in, maybe part of the answer would become clear. This is not just a singular object. This is a deep object. You know, it's got some depth to it, most likely. That's what I'm guessing. So this might be the edge of a very large, wall that goes for some distance. So I think that we're actually looking at the edge of the illuminated dark nebula here.
Yeah.
Yeah, that's what I kind of think.
Well, if we could see that from the side instead of edge on, maybe it would look more like the fainter nebulosity over farther to the right.
Maybe so. Yeah, very good. Very good point. Because if you saw this edge on, and it's not just flat against the sky, this is also in 3 dimensions. But
Yeah.
edge on, nebulae look brighter than when you look at them through the wispy, tenuous middle. You know? Jesus.
Izabela, what would be interesting to see with this image, since Marc has come up with techniques for getting rid of those halos around the bright stars like Sigma and Alnitak, it would be interesting to see what it would look like once he does that, if he does that.
Well,
I bet he does.
Keep in mind, there's so much more we can do here. Okay, now Izabela says, "Oh, these images don't need me." Oh, yes, they do. Okay, you see this convolutions in here, the dark and light areas. See how the same here? These dark and light areas are very complex interactions of clouds all wound amongst each other. Okay, dark dust lanes and dark clouds all wound amongst each other. So this area definitely would benefit from processing. I mean, just look here. Okay, I showed you this before. I'll show you again. Look at this wisp right here. It continues down. Right there. See that? It continues down. Well, that's brownish, right? That's brownish material. So is this. It's soot from countless past supernovas that have been gone off in this region. And it's part of what makes the Flame Nebula look like a flame. Okay, it's this superimposed material, this dark material in front of the brighter area behind it. Okay, and maybe that's a tongue of stuff sticking out over this edge here. Who knows how much further this is from, say, this. But we do know that it's 3-dimensional, and we're looking at almost like this is a lampshade and the light is inside.
Yes.
Aiming out. And that's just really beautiful. We don't see what's illuminating this nebula from here. That may be inside here.
That's a good analogy. It's like seeing a Tiffany lamp.
Yeah. Now, but I think Alnitak is responsible for ionizing all of this hydrogen we see here. But you do see the glow. It's self-luminous. Okay, it's self-luminous, meaning it's like a light, as Daryl said, like a Tiffany lamp. But this dark material is out here, and that light is out here.
Yeah, it's closer to it.
Inside.
Yes.
Yeah, the black is here, and the lighter stuff is way back here. So that's why we see it this way. And it's almost, you could spend a whole night just looking at one piece of one image. Wow. It's almost like I don't want to move on, but I know I have to. Because there's even greater, more interesting things to see just in a moment. Well, this is probably by now the PNG files up on the server site. If Izabela, you can put the server up there again. Oh, she already did just now.
Already did.
Thank you. Already did. All right. Giggity giggity. All right. Okay, so it's not gone. It's not forgotten. It's just stored in memory. Okay. Now let's go and set our exposure back to 1 second. This has been a banner night. Everything we looked at has been phenomenal.
Oh, yeah.
Everything we've looked at has been beautiful tonight. Nothing is a waste of time. Except the JWST so far.
I noticed on that short exposure a few seconds ago, it was short enough that you didn't see the halo around Alnitak, and we can
Yeah.
see that other star right at 12 o'clock, directly above Allen Attack. I want to say we've talked
Right
about that
there.
before. Yes, whether that's actually a double star of itself. I'd have to look that up.
Well, maybe you would. Let's go and check it out first. Let's go here. Let's go to Allen Attack. Let me go to Allen Attack here. I'm going to move into Allen Attack. Allen Attack on the Lam and Mintaka. Okay. It is a double star. But that may not be the double. It might be spectroscopic binary.
I know.
Or what we're seeing is the star. All right. Now, here is where we are. And we're so close to this beautiful object. Should we check it out? I think we should. Nah, I don't want to do that.
Sure.
Actually, I don't even
Oh.
I don't even have to do it this way. I think we can just drop down to it. So let's do that, shall we?
Yeah. Well, this is about, M42. This is the best thing you can see in the northern sky, folks.
It is coming right up.
Yep.
These two things we just showed here, the Horsehead and the flame with all that nebulous detail, you're not going to see that in a regular telescope. You need a longer exposure to see all of that.
I saw the Horsehead once,
Yes.
visually, by eye in a telescope, but it was
Uh-huh.
really dim, and that was using a filter to see it. But you
Yeah.
could see it. It just looked like a little black nudge in that line there. It was like black on dark gray.
I believe it. I believe it. Okay, so let's... Okay, so that's actually pretty close. All right. So we're going to drop down now. Okay.
Just a second. Be right back.
Okay. Well, we're going to look at this, and then we're going to go. We're going to leave it. Okay. So now, there's the Orion Nebula. And it is going to... You're going to be stunned by it if you haven't seen it in here yet. Actually, let me bring my speed down.
Okay.
Okay, here we go. Now we're just going to go whipping by, so get a good look, kids, as we go by. Problem we have with the Orion Nebula is it's near the celestial equator. A lot of satellites in this region. So we end up seeing an awful lot of satellites zipping through here. Okay. So this is the Orion Nebula here. This is called the Running Man Nebula. But in between here and all throughout here is pillows, little like pillows of beautiful brownish dark nebula. And that's our target for tonight. We're going to look for that. This is overblown. If you actually, this is a 1 second exposure and it's too much. If I actually, cut it back here, then you can see inside. And there's 4 stars in here called the trapezium. And these stars actually light up this nebula. All right, so let's go to 100%. And even now, you can't see these 4 stars. Even now, at 1 second, without any added, processing, you can't see it. I would have to take the gain at 1 second. I'll have to take the gain, say, down to, say, maybe 25. Would that do it? Let's see. There we go. Now you can see those 4 stars. The gain is the sensitivity of the camera. Let's go to 50. And they should be a little brighter.
Izabela, no, you can't. Not easily. Not remotely.
What'd she say?
She's wondering, is it possible to rotate the camera or whatever it is vertically?
Oh, I wish I could, Izabela. That's one of the things that would be nice to do. It certainly would be nice. Okay, so let's now
I see
go
Bill
to
Murray.
30 seconds. Yeah, Bill Murray. I don't see Bill Murray. I never saw Bill Murray. Not one time ever. Okay,
Bill
hold
Murray,
on. Actually,
Caddyshack. He's eating the baby Ruth.
yeah. Okay, I can tell you that we need to stay at 1 second for a while because the temperature's dropped enough. Sorry about the cough. I'm not sick, but I have a paralyzed vocal cord. So in the winter, because it's chilly and I have dry air, warm dry air in the house, it's causes problems. Okay, this, you can see this is not quite in focus, so we're going to focus. This is our 1 second shot. Let's bring up our focusing system. Okay, and let's go back. Temperature is 36 degrees now. Fahrenheit in there. Alright, and so let's go here and let's zoom in. This is 100%. Let's zoom to 200%. Alright, and let's take our camera controls and let's go toward that hybrid view where things are brighter. Alright. So now, in our live view, let's see. Let's try this guy. These are 3 of the ones that have worked in the past. That one may not be good, but we'll find out. Right, it's not. But now maybe this one might be good. If not, we can do anything in between. It's not a problem. Okay. 48,190, 48,216, 48,130. Okay, that looks better. Look at the satellite going right through here. Look at that. Told you, look at the satellite. Right down here. Right through the Orion Nebula, Daryl. How dare it go through our Orion Nebula? Look at that.
Thanks, Elon.
What'd I miss?
Huh?
What'd you
Nothing.
say?
I was just saying.
Thanks, Elon. Oh,
Thanks, Elon.
duh. I got you now. Okay, 48,130. Looks like a good focus location. Let me see if we can drop it down a little bit more. 48,098. Yeah, see, I don't think that's good. I think 48,130 was better. Okay. I think we're good here. So we save that one. As the temperature changes, we go down in our focus numbers, so to speak. Okay. Now let's back out. Go to auto size for now. Go back in here. This is what our process shot will look like eventually. Now we're going after all the dark nebulae around here. Alright? So just to show you just how complex this area is. Alright? 30 seconds. And we're off. Here we go. That's funny. Weird guy says, it was the Jupiter too. Yeah, sure it was. I watched the new series. It was quite good, actually. I liked it a lot.
I've never seen it.
Have you seen the new series?
No.
Oh, okay. See all the satellites? Just can't escape them.
Oh.
Yeah. This is an area that's just full of satellites. You cannot get away from them. Okay, so here's what we're going to do. We're going to get this down here. Let's get a color correction in here first. Right, and now maybe, yeah, this reduces stuff a little. Just, I want you to see how much dark nebula is hiding in the background here. Okay, so now we're going to do that. And look at this. Look at all this. So you see, you're used to the Orion Nebula. But are you used to the Orion Nebula with all this additional nebula? Let's go exploring, shall we? Let's take it up to 75% of the full frame. And now, let's jump up a little bit. Look at this. Now, this dark modeled look here is going to get more clean the more that we stack. Daryl, this is phenomenal, Daryl.
Mm-hmm. I see Arnold Schwarzenegger now.
Oh, jeez. Everybody down. Get out. Don't talk to him like that.
You know what I mean. The Running Man.
The Running Man, yes. Stick around. Stick around.
I kill you last, Sully. You're a funny guy. I kill you last.
You're a funny guy. I kill you last. Yeah.
Commando, if I remember right.
Mm-hmm. See this? Look at this material here. This is just so dense, and once we, I'm without words, guys. I am. I'm kind of speechless. This looks like we're taking pictures of clouds. It doesn't look like we're taking pictures of the universe. And you know what's crazy? This is live. This is live. It's happening now as we see it. This is not a photograph I'm trying to peddle. This is live. You're watching it develop right before your eyes. This area here in the Orion Nebula is called the Bay. This is vastly overexposed right now. Because as I said, I'm shooting for this stuff right here. So, wow. Let's back out a little. See, it helps put it in perspective when you see how a bunch of hot young stars cause some glow. And this, now remember I told you about the nebula and how the hydrogen gas glowing from within a blue nebula looks. What does blue and red light make together? Okay, it makes purple. And isn't this purple? See, it's making kind of a purpley color here. And it depends how far immersed into this nebula this thing is. It could be far in here, and there could be more dust out here this is passing through, and so it has that kind of look to it. Dust is very good at reddening stars. It's very good, as you can see, a lot of reddened stars in here. And it's also very good at doing those complementary color things that it does to make the colors change. Outstanding. Wow. Oh, I don't know. Look at how complex this is, Daryl. I'm just like blown away by this. And now
blue
for the
and
first
red
time,
light make magenta.
yeah, and that's what we got.
Yeah. You had me
if you
confused
notice,
there for a second.
Oh, I'm sorry.
You're talking about color theory, mixing blue and red paint versus blue and red light.
Yes, it's not the same. You're right.
Yeah.
But look at this. This is the first time I noticed that this right here, in this Running Man Nebula, this right here,
Yes.
is actually has a little window in it, and you can see the nebula behind it peeking through. This is not something in the foreground. You're looking through a tiny little window peeking into what's out there.
Yep.
Yep.
The Running Man itself is M43, is it not? I think it is.
No, that's NGC
No?
1977. M43 is this guy, isn't it?
I'd have to look that up. That's part of the main nebula. I was always thinking it was right next to it, which would have made it the Running Man.
It looks right next to it here, but it's really not.
Yeah.
Let's go take a look here. All right, let's go down into this now. Hey, stop. I'm getting a slow internet right now. Out in the observatory. All right. That's it. Now zoom in. Okay. All right. I thought that this was M43 here. And this is NGC 1977, isn't it? Yeah, see? NGC 1977. So M42 is the nebula. M43 is this other little area near the bay. Wow. And I wonder if tonight we could actually see... Oh, look at this. Holy cow. It's like we're looking at art pastels. We're looking at art. We're looking at paint on canvas. Wow. This is the kind of thing that energizes me, guys. This stuff right here. It just totally energizes me. Look at that. Do you see what I was saying, Daryl?
I'm sorry.
Did you see what I was saying about NGC 1977?
Yes, I think so.
Okay. Now look at this. Way out here, okay, we have this object. This is yet another really interesting segment. It's related to the same molecular cloud as everything else. Because our internet is slow right now out there, you can see patchwork stuff. That's not really going to be on the images. This is so beautiful. Holy cow. Wow. Look at that. We should go for the Witch's Head. You know that?
Sure. It's big.
I know. But I want to catch a piece of it.
Yeah.
Okay, we
M43 is
stacked 21.
also known as
Say again?
D. Moraine's Nebula,
Yeah, that's this guy.
NGC 1982. But yeah, it's that little bright crook corner on the
Yeah.
just off M42.
Yeah. They're seen as two separate objects, oddly. So what the idea was tonight, on this nebula tonight, guys, was to check out all the stuff around the nebula and in between the nebula. Now you can see how these two nebulae are related. They're all connected in the same dark nebula. Isn't that cool? That is just so beautiful. And then when we back out and go back to our overall auto-framed view, look at this. Now, this cloud here you can see is overlapping the bright part of this nebula, and it extends all the way down here. See that? And it goes down here and around there. The Orion Nebula has been studied for hundreds of years, and there are new stars forming in here, and we're going to be seeing a lot more of them, you know, with the James Webb. Wow, this is just beautiful. Wow. Let's jump up to 100 for now. Look at that. Here is this area here. This is oxygen that's ionized. That's beautiful. Now, oxygen, when it ionizes, you know, it's doubly ionized oxygen, and it glows blue. The atoms of oxygen actually glow blue. They're actually the oxygen atom has a number of electrons, of course, and if two of those electrons get knocked off the atom because they absorb energy, ultraviolet energy, when they recombine with the atom spontaneously, because once they're off the atom they lose energy by hitting other things, they come back into the atom and they give off a characteristic teal blue light like you see right here. Okay, and in the case of hydrogen, right, hydrogen gas gives off a characteristic red light. All right, this is a dark nebula here, but this characteristic red light is from the one electron getting bounced off the hydrogen atom and coming back in. And that's, of course, ionized hydrogen. You can't have doubly ionized hydrogen because it only has one electron. All right. So that's pretty neat. And these red stars could be red dwarfs, but more than likely, these stars are probably stars inside the dark nebula. They're in here, they're back here somewhere, okay? And they're reddened by the dark nebula between you and where they are in the nebula. It's just, Josh, I cannot wait to process these.
Mm-hmm.
Ay, ay, ay. I mean, they're processed now. Beautiful. Okay. Let's stop this. We're going to stop this now. We're going to say pause. Well, actually, we're going to wait for the 30th one. And there we go. Pause it here. You notice how the noise is all gone now? There's no noise in there now. There's noise, but not a lot. Now we'll save the stack. Okay. And then we're going to save it exactly as seen. So this will be up on the server in just a few minutes for you guys to enjoy. Okay. Alright. So there we go. Kaboom! So much not seen. I want to tell you something else. I was using a 24-inch Cassegrain to do my thesis research in astronomy, and I turned it onto the Orion Nebula, and I took photographs of the Orion Nebula. And what's interesting is it was a 24-inch Cassegrain, but it was a rather slow instrument. Uh-oh. I guess he yawned. Does that mean something? It was a rather slow optically. So I took like a 45-minute shot of the Orion Nebula. 45 minutes! And what we got here in 10 seconds, 30 seconds, was unbelievably better than what I took. See? And this is a telescope that's more than, it's less than half the size. Amazing.
OG
James, okay, OG Skywatch. Yeah, okay, you're seeing it too, yeah.
I'll let you answer
yes.
that.
Okay, he says, will James Webb increase or solve our understanding of dark matter? Also, will it cause us to have to rename or re-theorize our understanding of a lot of stellar objects? It's going to see objects that we haven't seen before, OG, for sure. As far as will it increase our knowledge and understanding of dark matter, you know, maybe. Right now, there's no instruments we have out there that can really see dark matter. We see dark matter only through inference. We see its actions on other visible baryonic matter, matter that is like neutrons, protons, electrons, muons, gluons, and so-ons, as I say. That's baryonic matter. But dark matter is not in that category. Dark matter seems to be something else that's outside that realm. Okay. So that said, I think that we're probably looking at something in the range of the Webb that may or may not fall into the dark matter category. I don't think it will, because it's baryonic matter that the James Webb is looking for, and light from phenomena that baryonic matter create. But if there is an influence by dark matter on something that the Webb images, we'd see that influence. But I don't think we're going to see dark matter with it. No. Okay. All right. Let's back out of this for a minute. I think.
Thank you, Izabela.
Oh, thank you, Izabela. Izabela once again has given you the link to the live server.
Oh, you gonna try the witch's head, I guess?
Sure, why not? Trouble is, we have to go to the brightest part of it.
Suggestion maybe try to get Rigel right outside the field of view.
Yeah. Yeah, and that would put us, like, that's why I'm saying this star. See, because that would put us here.
Yeah.
See? Okay. Let's see if we can go to the star. It's probably going to go to Rigel. But we should be able to see it. We should be able to see it. Okay, there it goes. It's not going to Rigel anyway. Maybe it is. Let's go check. It would. I don't have this illuminated right now. Yeah, it's going to Rigel. So Rigel is the object of interest. Okay, so that's there. And then we're going up to that star. Shaboom. And we head up that way. And that would be that star. Remember last time we tried looking for this and we didn't even see it.
Yeah.
But what kind of night was it? I mean, where were we I didn't remember.
Speaking of, have you checked your weather again lately?
I don't want to see it. Let's find out. Okay. So far, we're holding our own.
Yeah.
I was just looking at this guy's over here. Again, this is the observatory in the Arizona desert, and we're still holding our own. So back to the main screen, and let's give it a try. Shall we? Yes, we shall. Okay. Oh, I think I see something here. Okay. Now we're going to do a 30-second shot here. Okay.
Folks, if you've never seen this, the witch's head looks just like the Wicked Witch from The Wizard of Oz.
I'll get you, my pretty. Now we're going to clear this. This beautiful object will be cleared for now.
What did I say, Bonnie? She's shushing me.
Okay. Hey, we got it. Look at this. There it is.
A little bit of it.
Yeah.
That's her chin, I think. Her head's upside down.
And we got a satellite, too. I should move this up. I'm going to move it up. Okay. So, we're going to stop this stack. And I'm going to move that star up to about there. And bring in more of this object. Alright? Alright. Last time we tried this, we didn't see it. And
We didn't see squat.
We did not. And tonight we are seeing the whole thing. Well, we're seeing it better anyway. So this star has to head up more. I told you I thought I saw something here, didn't I?
Uh-huh.
Alright, so let's drop it down a little bit now. Hey, DK, thanks, man. Thank you very much.
Thank you, DK.
It's very obvious tonight. I think it was probably too low to the horizon when we tried looking at it.
Mm-hmm.
'Cause there it is.
Oh,
You can't miss it now.
That was a while back.
Yeah. Okay, let's just go up, bring it up as high as possible. Because I see it here. Now look at this.
Yes.
There's a lot down here. Wow. Okay, we're going to go more than 30 seconds, too. We're going to take this for a spin at 50 seconds. Alright, so that's good. And it's actually, look at the telescope, it's right there. It's pretty high in the sky, so we're actually, we're getting close to being able to look at the Rosette Nebula. Okay. Guide star is certainly being picked off. And we're going to go 50 seconds right now. And away we go. Live stack. And this is the previous image. Notice how dark it is? It's going to be a little bit brighter now. And that satellite is probably going to be about here. Maybe over here now. Oh, this is so exciting. See, when stuff like this happens, I don't get tired. I may yawn a lot, but I don't get tired when this happens. This is just beautiful. Okay, you ready, guys? Oh, I'm so scared. Vera, thank you.
Vera.
Oh, look at. Wow.
See her chin,
This
her, I guess her mouth and her nose, and
Look at that. This is gorgeous.
that's her eye to the right of the nose. The nose is the thing sticking out toward the bottom.
Oh, here.
A little higher.
Okay, like this.
That's her nose right there. And I guess that would be.
I don't see her.
Hmm?
I don't see her.
Seriously?
I don't. Alright, let me, I actually just gotta take and try and increase the contrast between the background and this. Okay, we'll try this now. Hey there, Angus. How are you? Okay. Look at that. Wow.
Yeah, that's her chin at the top. Then working
Top.
your way down, that's her upper and lower lip, lower and upper lip. Her mouth is open.
Oh, I see what you say. This is her nose.
No,
Oh,
that's her nose down to the lower left of where your pointer is. That's her nose right there.
And it's upside down?
Yeah, the whole face is upside down. Chin is at the top. Her mouth is
Okay.
open. Her lower
the
lip
mouth?
below the. Yes, that's the mouth. It's her lower lip, and then her lower lip above, upper lip below. That's her upper lip. That's her lower
Upper
lip.
lip here?
That's her
Okay,
lower
the
lip.
upper lip.
And that's the upper lip.
This is the upper lip.
Yes,
Upper lip.
because her head is upside
Okay.
down. And
Right.
then her nose sticking out down to the lower left. Right there. And I guess her eye socket there to the right.
That's a real ugly witch, man.
Yep. Izabela says she sees it.
Yeah, she's probably turned her head upside down. I haven't. I see it. Okay, first things first. Let's do some color correction. Yeah, that's a little better. And you're noticing... Oh, look at that. Wow. This is a very subtle color, isn't it?
Mm-hmm.
But it's really pretty. Alright, so now let's do this. I don't know if this is good or bad. Let's see how that works.
You upped your exposure time, didn't you?
50 seconds.
Okay. What's your gain at?
350.
Okay.
I don't change the gain too much because, you know, I set the gain really low when we want to see detail on very small, angular sized objects.
Yeah, well, I remember you
I
turned the
dropped the
gain
gain.
down earlier. I guess you
Yeah, let me
returned
show
it.
you. I did. It was down to like 20 and 30. Now it's up to 350.
Yeah. Okay, I believe you.
I mean, this gain will go to almost 600. All right, but
Well,
it gets noisy.
No, yeah, it's working.
So I don't want to do that. Yeah.
Never
But-
mind.
Okay, what I could do is this. I could actually increase how it looks by moving this guy over too. Right, but it just also adds a lot of other
Yeah,
extraneous noise
Right.
into the mix. But that's
kind
there,
of washes it out.
It does.
Well, congratulations, you got the witch's head.
Yeah, we did. Looks nice. Looks really nice. Actually, we could do this. Alright. Yeah, maybe a little more. I'll show you what I'm going to do. Okay, so it's going to look like it's too bright. Then we come in here and we modify the dark level.
There you go.
Okay, and by modifying the dark level, we get this. Now, you'll notice this sort of reddish glow in here.
Mm-hmm.
This is a phenomenon of the sensor, and the way you correct this is by doing something called a flat field. And the flat field is usually done by taking like a t-shirt, covering the opening of the telescope, and lighting it evenly, and taking pictures. And you add those together and make a flat field. And it's really just shows the sensor response that you get in cases where you see, you know, the light things in the middle. Well, I wasn't happy with that because I can't get access to the telescope to do this. So I wrote a synthetic flat field system that is actually part of Photoshop. I put in Photoshop. And what it does is it corrects for this center brightening, but on a per picture basis. Okay. So whereas this looks like some kind of weird planet right now, this round object, part of this round object is an artifact. What's really here is just this thing. So what you do is you remove this thing, and then you can actually get rid of this guy by subtracting that object from this original picture. I know that's kind of hard to understand, but then that gets rid of this, and you get a total flat field.
Mark, can you open the Stellarium view for a second?
Sure, we'll let this keep stacking.
Sure. Yeah, I think we're missing a little bit out the bottom of the image here.
Oh, we are for sure. It's bigger than the view.
Yeah.
Without doubt.
Thank you.
Yeah, because we're seeing to about here.
Yeah.
And a little bit, but yeah. This is just so cool. That's neat. There's been no failures tonight.
Mm-hmm.
Yeah. Another first. Okay, so what I'm going to do is I'm going to reset. No, not that. That wasn't right. I don't want that. That's fine. Okay. So now let's go in here. And let's do this again. Right? And do this again. Okay. And now we're gonna do.
I think that's really cool.
Yeah, it's just too bright. So that's going to be the one that will correct for the flat field. So that'd be good. And it's not the whole thing. So now when you see this, see, now you get more. There's a little wisp over there, look. This isn't bad. 13 stacked so far. Let's go to 100%. Check quality. Quality control. Doesn't look so bad. The wisps stand out very nicely. You can see these green trails. These are artifacts caused by the sensor. You'll see red ones, green ones, and blue ones.
Mm-hmm.
Wow, that's something. I'm telling you, and we're just scratching the surface, guys. Though the DK, this is being stacked. This is we've got 14 of these stacked already. So that's what we got 14 stacked already. All right, let's go back to auto. Okay. And while this is stacking, let's go look for the next object we want to check out. We have a lot of dark nebula in here, which is kind of cool. think this is a H2 region. Yeah, it is. Okay. The LBNs are H2 regions or stellar nurseries. Usually smaller ones. Okay, so it's amazing that there's a galaxy right near the Orion Nebula, visible through all that dust.
Mm.
There's one down there, there's one right here. That's a galaxy beyond our galaxy. Magnitude, what's magnitude that is? Saying 13? Yeah, 13. That's more than bright enough for us to see it, but it's actually pretty dim for a regular galaxy. Okay. This one here, 12.6 magnitude. Okay, we're still doing the Witch's Head. I wonder if we've managed to stay out long enough to check out. Probably not that, but I think that we're gonna be able to do the Rosette tonight. I think the Rosette is quite visible right now, so we'll check the Rosette out. Wow, look at this, Daryl.
Yeah.
It's 18 stacks so far. I think we'll stop with that. Okay,
Well done.
so we're gonna pause the stack. What's that?
Well done, I said.
Oh yeah, it looks like it came out well. All right. And thank you. Okay, save exactly as seen. Okay, now we're gonna clear this. This will be up there in just a few minutes. Now what we're gonna do is go to the Rosette. You didn't see the Rosette live. You saw it only in the photo I sent you, right?
I have seen it on your live stream so far.
But did you see it this year? I mean, the way it looks now? Since collimation and all that?
I think so. I know you
Really?
showed me the image, but I think we hit the Rosette one night before.
Did we?
I want to say I was there, sure.
Okay. You might be right.
Do it again.
No, we can't repeat any objects. Yeah, of course. We're going to do that.
Sure you can.
Yeah, we are. Okay. So now, let's go back. And from here, let's tell it to go to the Rosette. I think we're going to be clear aperture on this one. So here it goes. Yeah, we're going to be clear aperture. We're going to be good here. All right. All right.
Another object I have seen once in my life.
What's that?
Rosette.
The Rosette?
13-inch telescope with a filter on it.
Oh, okay.
And it was gray, not red, but you can see the shape of it.
Okay, guys, watch this. You'll see it. There it is. There it is. Oh my gosh, this is going to be one of those spectacular images tonight. Holy cow! Wow! Let's drop it down.
Me and my star chains There's that one at about 10 o'clock from the center of the nebula. Kind of got a hook shape
mean
to
this?
it. Yes,
This guy right here?
yes.
Yeah.
Make a guy wonder.
Yeah. Okay, you guys, you ready for this? You ready for this? This image is gonna change the way you think. Because it's stunning. First things first, let's check our focus again, make sure we're at critical focus. I'll go to 150% now. Get really close. Oh, that's not bad at all, Daryl. That looks really good. Look at those small stars those are. This is good.
Yeah.
Very good. I'm so excited for you guys. You ready? This is a telescope's getting its guide star. It's probably got it by now. We're gonna do 45 seconds on this. We don't need to, but we're going to. And here we go. Oh, this is so exciting. Oh boy. Oh boy. Oh yeah, this is. All right, folks, get ready. This is gonna be a beautiful scene. You're just gonna love this. DDB, hey DD. Halfway there. 15
You're still doing
seconds.
longer exposures.
45. 45 second here.
Okay.
5 seconds. I gotta get ready for this one. Watch this. Here it comes. Oh, wow. Okay. This is one of the most beautiful nebulae in the sky. I can tell you right now. Right? And it's definitely worth a maximized view. Look at that.
That's something.
Look at all this additional nebulous detail. Wow. Yeah. Holy cow.
Colors
Holy
look
cow.
a little yellow.
Yeah, they do. We can try a color correction. You see how the noise just went away? We
Yeah.
can try a color correction now. Okay, do it again. "45 seconds is almost too long. I'm in the way here. I'm gonna move. Oh, no, that. That was silly. I'm in the way. So I'm gonna move over here. Wow, look at that. That's beautiful. What do you think, Daryl?
I think that's a knockout.
So, get a little more detail by doing that, and you can see some of the convolutions of this nebula. You know, and don't worry about the colors. We can actually modify the colors appropriately later.
Yeah.
Wow. But
Oh, so much detail on it.
oh, yeah, I know. This is Get some of the red topped out here.
Refresh my memory. NGC 2244?
Yes, sir.
Okay.
Good guess.
Wasn't a guess, just
Well, good recall.
hoping I remembered correctly.
You did. Check it out. We're gonna go to 100%. I want you to see these dark lanes in here. Now, the noise is going to go in here, by the way, but this is very important because when we talked about the Bach globules earlier tonight, there's some right there. 1, 2, 3 Bach globules. There's something forming in there. The James Webb Space Telescope will look in there and be able to see what's going on in there. Here's a globule in the process. Everywhere we look in here, we see a bunch of fragmenting pieces of filamentary structure that are fragmenting to become Bach globules, like this right here, that right there. You know, these are the locations where planets and new stars are going to be formed. You know, and these globules right here, these guys are really the precursors to these new solar systems, if not just new stars. They'll certainly be new stars too, but you're also going to get new planetary systems in there. Now, early on, they're not going to be able to survive, and I apologize for this weird thing. I'm wearing a two-tone shirt. That's why it's doing this. Early on, they're not going to be able to support having life around these planets, okay, because of the fact that these are going to be this is the way. These are going to be an area where it's going to remain hot for a period of time, but that's going to change. That'll change, you know, because over time, what's going to happen is these stars are going to migrate away, move away, and the ionization energy is going to drop, and the next thing you know, they're going to be able to have dark nebula once again. It will return to being very cold, which will form the basis of the ice grains that will be in these dark nebulae, and then those ice grains will coalesce, stars will form, and there'll be a bunch of material that's left there for use in planet building. Wow.
Where you are right
so complicated.
Right now,
Yeah.
over on the left side, from the top going down a little more than halfway, that skinny red strip.
This or this?
Yes, both of them, all
Okay.
of it, all that long,
All right, yeah.
skinny strip. And up at the very top, red strip there where it has that hook at the top, you can see 4 stars delineating that red curve. Me and my
Right
star
here?
trains again. Yes. See 3 there and
I
then
see
one
that.
over the hook there?
I mean, this one or this one?
That one.
Yep. This is really cool.
Such detail.
I know. It's just astonishing. It almost looks like paint spilled on a canvas. You know? This paint spilled on a canvas. If any of the streams should go viral, it should be this one. It shows so much going on.
Yeah.
Let's do this.
Excuse me for a moment, please. I'll be right back.
Okay. Wow. Look at the center of this, guys. This is just incredible. Look at that. This is just beautiful. This is, again, a stunning stellar nursery. The stellar nursery, these are the new stars that formed in here, a few million years old. And as I said before, these new young stars, they form a cavity around themselves of very, very hot particles of dust that's left in there. But it opens up this whole area and forms a big open cavity and pushes out with the powerful stellar winds to really pump out this big cavity. And it's really just an area where these stars ionize all this hydrogen gas. Just to give you an idea, this nebula overall is 65 light years across, right? So it's 65 light years approximately from here, okay, to here. 65 light years. All right. So these stars are sending out enough energy to ionize hydrogen 32.5 light years away on each side. That means that these are pretty hot stars. And whereas these stars themselves probably could and wouldn't likely ever be able to host life around any planets that might form around those stars, some of the other stars that get formed along the way out in the regions here in the dark, the devil's in the dark, you see. And so any regions out here where stars form, these might actually be the locations where planets could form. And Daryl, yeah, I think you're beeping. It's sort of it's a computer noise with your microphone. You know, it's a little interference pattern. You're not actually beeping. It's a high pitched, you know, like every now and then. It's electronic whine that's cyclic. And that's what they're hearing.
Mm.
Look at this. Wow, look at this. Look at it's really stunning. Let's see how that's gonna be a little darker. I want to brighten it up a bit. Wow. Look at that. So is that worth the wait, guys? Tell me in the chat. I'm not beeping DK.
I don't hear anything.
I hear it right now. It's an electronic noise. It's an electronic hum that's cyclic. When your microphone's off, it doesn't. We don't hear it. When your microphone's on, we do. See right there? I hear it now. It could be as simple as moving the cords, moving the earbud cord a little bit to one side. It's not bothering me. I mean, if it's bothering somebody else, then that's why you're hearing about it. What do you think, Bonnie? Isn't this a beautiful object? The Rosette Nebula.
Well, I rearranged my cord, so that doesn't do it, I don't know what to tell you.
Yeah, it's still there, but don't worry about it.
I
If
can't
they
help
can't
but worry
handle
about it now. Darn them.
These evil people in our chat. Oh man, this is something else. Let's see what else we got around this area.
There's Christmas Tree cluster.
Oh, you got it. Yes, sir. Oh, Donald Kunzer asked a good question. You know, could the Webb get enough information using its infrared systems to make a 3D model of a object like this? The answer, unfortunately, Donald, is I don't believe so. And the reason is because the Webb telescope is not going to be in a position to gauge the distance to the different elements of the nebula. It's not set up for that. And in fact, neither are we. It's far away, so that thousands of light years away, such that we can't get what's called a parallax to it. There's several different kind of parallax. There's dynamical parallax, statistical parallax, and so forth. And parallax is a way to calculate distance to relatively nearby objects. But it's not going to be something that the Webb can do, unfortunately.
You know, that brings up a question I had. I think I recently gave you a link to that Spitzer infrared telescope video floating along the Milky Way.
Yeah.
And I'm sorry, go ahead.
No, I said yep.
Oh, well, speaking of parallax, if you watch that video closely, it's like they're trying to make it 3D in that the stars appear to be foreground objects, a lot of them, and you can actually perceive several different layers. You know, things farther in the distance are moving slower. I wondered if they could have integrated information from like the whichever satellites they were that were doing, you know, stellar distances, and worked all that in there, if they were just taking liberties with it.
I don't know. I don't know if it was just an artistic thing or if not.
Yeah. I mean, it was well done, however they did it. I don't know if it was real or not.
I don't either. Look at the detail in here.
Yeah.
Look at the detail right here. Is that not incredible?
It is.
Wow. That's... I don't know what to do. I can't say. This nebula is huge. That's right, DK. It's 65 light years across. And there's Daryl's star train right there.
Bunch of them.
Yeah, you can't miss them. They're everywhere.
The more you look, the more you see.
Yeah. Wow. 23 stacked. Interesting how this particular nebula looks like it has, I'm going to zoom out for this. Looks like it has a multi-level. There's this yellow nebula, which is not really yellow, it's red. But it looks like it's probably the closest into the stars. Then there's an outer dust ring this here is backlit by material behind it and also by the glow of hydrogen. It's dark nebula, it's dust in here. But it's the light penetrates the dust, and so it makes it look backlit. But then you've got another outer ring here, which is just amazing, and then a soft glow outside.
Yeah.
This is an exceedingly hot location, radiation-wise.
Yep.
There's no surviving here. Wow. Look at that.
More's the pity.
Like a little... What?
I said that more is the pity.
Oh, yeah.
And I'd love to live on a planet that had something like that in the sky.
Oh, that'd be something.
Probably not for very long, but...
Yeah. Well, the only problem is that you would end up, having to endure a number of supernovae from that direction.
Yep.
At some point.
Probably need some SPF 15,000 sun lotion too.
Yeah. As if this was, if this filled half the sky, I would imagine that the UV radiation from those stars probably wouldn't hurt you, but a supernova would.
Oh yeah.
That's the only problem.
SPF 15,000 wouldn't cut the mustard then.
No. Okay, 26. We're going to pause here. We're going to save it like this. The stack is being saved. And then we're going to save it exactly as seen. The stack is not processed, by the way, but all the data is there. So you do that on your own. But the save exactly as seen looks like you see it right here. These are beautiful. Wow. All right. There's so much
one more
in this. Yeah, I know, right? It's the one more. It's the.
Yeah.
Mark one more to Antonio.
I'll go one more object. We're going on 5-hour stream.
No, sir.
Yeah.
Holy cow! 4:45. See what you do to me, guys. Okay. What about the? Ooh. I don't think we can see Thor's helmet yet. But we can see the Christmas tree. Should we look at that?
Sure. And the cone and the other stuff are all there too, aren't they?
That's right.
Yeah. Be a good one.
Yeah, we could actually. As a Christmas tree cluster, then we have this nebula. But you know what? Let's just do this one. We're going to do that. Okay. So. Okay. This'll get it. Off we go. And I will get out of my.
DK, Thor's helmet is Wolf Rhea star. It's in Canis Major, Mark?
Yeah, a little west of that. But
okay.
Yeah, east of that, I mean.
Yeah. Probably not high
It's
enough
like above.
up here.
Actually might be Puppis.
That's what I was thinking.
Okay. Might be Puppis. Okay. There it is. I'm getting slow reaction times on the telescope, which indicates that there's some overloads going on out there. So this will probably be the last object. This won't happen when we have Starlink. Starlink is coming in February next month. Okay. Looks rather nondescript. Doesn't look like there's anything here. You got this cluster here. You got this little weird nebula down here. But there's a lot going on here. Let's check our focus. We're in the same relative region, so I think we'll be all right. And we are. Yeah, we're getting some definite hits on our speed. Okay. Let's go here and set this to 40 seconds. And go. This area is rich in a very nice deep red hydrogen emission nebula. It literally fills the whole field. And that blue reflection nebula is in it too. But you'll see when I show you. Okay, here comes the first one. Look at that. Wow. And we can maximize this one.
Okay.
Okay. Oh, JSCO. Mark, you made my dreams come true. I've wanted to be able to see these beautiful objects with clarity all my life. Yeah, but as you say, what we're seeing has become reserved, or well, has been reserved for the very elite until now. I wouldn't say elite, but multi-million-dollar telescopes and observatories would take pictures like this typically. Look at that, Daryl. Look at that beautiful object up there, that beautiful dark nebula.
Mm-hmm.
Right there, you see it?
I do.
That's gorgeous. Yeah, you're not. That's true, and this here is the cone, right here. Yeah, and the noise is going to be lessened substantially as we allow more exposures to be taken. We've only stacked 3. In that time, if we go to 100% anyway, you can see how much noise is in the image. Okay. There is noise here in the dark part of the image, but the bright parts of the image, the noise is masked by the bright data, the brighter data. we go until the dark data becomes pretty much as soft as the brighter parts of the field. Yes, the Cone Nebula is this guy down here. That's the cone right there. Named for the cone shape. And we do have good focus because these two stars are actually quite well separated.
Isn't the whatchamacallit Heinz Variable Nebula, Hubble Variable Nebula?
Hubble's
Hubble's
variable, yeah.
Is that
Let's
just
see
out
if
of
it's in the
frame to
field.
the bottom?
Let's see. I had it in the frame the last shot. Yeah, it should be just below the bottom of the frame here.
Yeah. Oh well.
That's okay.
If you look at the bright star a little above center, folks, it's a Christmas tree, but it's upside down. That bright star is like the stump at the base of the tree, and it makes sort of an arrowhead shape pointing down, like a conical shape like a Christmas tree. And the top of the tree is just above the cone nebula.
Yeah. Very nice.
It is.
Oh, thanks, weird guy. Weird guy says, JSCO 77, I second that. JSCO said these are beautiful objects he's looked for, wanted to see a long time. And Weird guy says, the arc of this channel over the last few years, it's all culminated to this, and just wow. That's really nice to say. Thank you. This has been something that we have been aiming for, is to bring you these objects live. You just see them just like if you had magical eyes. Only we provide you with the eyes. And we see them a lot of times like you for the first time. I think that's pretty cool. I mean, through our systems. I've looked at the cone from here. I've looked at the cone in other places, in bigger telescopes, smaller telescopes. And it's never been as good as SkyTour LiveStream's shown us. I don't know why. Maybe because I really wanted to put the effort into making the objects look really good and processed before, remember with SkyTour East out here, you had to wait for me to process the images and then upload them somewhere. I didn't have a server at that point, and then I didn't have any way of doing the live processing like you see here. We're stacking live, and that's something we're doing now. We're processing live, that's something we're doing now. And it gives us a pretty good measure of what a final processed image will look like. And these images are gorgeous in and of themselves too. So it's really it's come a long way, and I'm just astonished by it. I keep pinching and no lie, I pinch myself and say, is this real? It's so beautiful.
I remember when you were sitting in the freezing cold in your little dome.
You remember that?
Oh yeah, and your teeth are chattering, you were so cold, and
yes.
You're getting numb and couldn't move.
And yes.
It's grown light years since then, pun intended.
Yeah. It has. It's changed dramatically.
Yeah.
Uh-oh, I think we're getting a cloud.
Yeah. Have it got light all of a sudden?
Yeah. I have a way around this. Not a way around it, but a way to check something out. So if we come in here, let's take this guy. We have an all-sky camera, and I'm going to change the settings, take us to, say, 15-second shot with the all-sky camera, and see what we got. I have to do it in milliseconds, which are a thousandth of a second, so it's 15,000 to make 15 seconds. So save, and then preview, take one picture, and now we'll see. Okay, here we go. We got clouds there. Let's go full screen. Launch full screen preview. Yeah, we're fighting clouds, guys.
Yeah.
Here's Orion upside down. That's south at the top. And we are, let's see, we're about here. So, there's some light clouds that are passing through here. Okay. But you know something? That's okay, right? I think what we found is we had a beautiful night, an amazing journey, a bunch of different objects.
Yeah. Hey, we're right at 5 hours now.
Oh, yeah. Well, let's go see if we can salvage this image, okay? Let's bring our system back up here. Well, that doesn't look bad.
Yeah.
I think we can salvage this. How many of are stacked here? We have stacked 15. So let's get out of this. That doesn't look bad.
Yeah.
That doesn't look bad at all. So that's okay. So, okay. So there's the telescope. There's a system. It's almost like I was planning on just staying up as long as I had to. But the clouds have different ideas. The clouds have different ideas, don't they now?
Curse you meddling kids.
Yeah.
Okay. Well,
all right, so I'm just gonna. That's a good spot right there. Okay, so we're gonna pause this. I'll save it right here. These will be available to you moments from now. Save exactly a scene. Okay.
well, Izabela's right on top of things. I think she needs a raise.
Yeah, she's good. Izabela, I should give you access so you can change the names on the directories if you want to do that, but you're already doing the chronologies, so I'll keep doing the names. Don't worry about it. Okay, let's see here. Alright, I'm going to pause this right now. I don't want to do more frames. Okay. Wow, this was a great night. This was a good night. Good, solid night with lots of good things. We got some objects we haven't seen before. we got objects that we have. Primarily, the witch's head looked really nice.
Yeah.
All right.
Oh, that
So
feather in your cap all by itself.
Well, it's a lot of fun.
Sure.
Okay, for sure. Okay, we're going to disconnect the telescope from the planetarium system. And then exit this system. There's an order of exit. Okay, and then we're getting this. And get out of this. I know why I want to continue, but we can't. Okay, this focus right here, 48,130. I now have as a stored value. What's the final temperature in there? 36.3 degrees Fahrenheit. And what are we? 2.2 degrees Celsius. Yep. Okay. So now we know what the focus needs to be. Okay, disconnected. And the focusing system goes to bed. Good night. And then, what else do we have? We just have this guy. But we're going to leave him up for now, because what we have to do is we have to park our telescope. So this telescope is now going to park. And that means go to its stowage position. Well, there it goes. You watch there. It's going to move down to its location where it's going to store itself. And when it gets into the final storage position, there it is. And now we can turn the telescope off. And the telescope is now off. You'll notice that the stars are moving gently across the screen. You're actually watching the Earth rotating out from under the stars. Okay, now we can disconnect the scope. Alright, scope is disconnected. We can shut this down. Yes. And then the camera, we shut down. Camera shut down. We can close this system. Remember when the telescope wasn't alignable and it couldn't see where it was going, and sometimes we get all messed up and go spinning out all over the place?
Mm-hmm.
I'm really hopeful that that's a thing of the past now.
Well, it looks like you got the bugs out of it.
I hope so. I hope so. Okay, now what I'm going to do is the last thing, which is kind of fun, because I just never gets old. That is, I'm going to just say goodnight and shut off the roof. Shut the roof off. Shut the roof up, I should say. So here we go. Let's send that. And now we're closing the observatory. There we go. Odd that this is happening 2,500 miles away.
I want my flying car, damn it.
I know, if we could do this, we should have a flying car. Wow, that's cool.
Bart Simpson said, God schmod, I want my monkey man.
God, Schmod, I want my monkey man.
That's funny.
Thanks for coming, everybody. And
Yeah, guys, thank you.
have a good night till we meet again.
This is wonderful.
Say goodnight,
Yeah,
Gracie.
we will be back on the next clear night, perhaps. I'm gonna do get another status on the Starlink out there. So we'll see what happens.
Okie dokie.
All right, folks. I really enjoyed having you out here. Thank you so much for coming. We had a great time. I know Daryl had a great time.
Yeah.
So we did all right tonight.
It's another landmark evening, I think.
I think so.
Okay.
I think so.
Take care, everybody. See you soon.
All right, guys. We'll see you later, and we'll talk to you again.
Good night.
Good night, everybody.